Biotechnology at Svhec Engineering College from February 24th to March 1st, 2025. Today marks the day 4th of the Enriching FTP. On behalf of Sri Venkateshwara High Tech Engineering College, I once again extend a warm welcome to all of you for the day 4, session 7. It's my privilege to extend a special welcome to our esteemed session speaker, Dr. S.R. Prabhakaran sir, Professor of Center for Biotechnology at Annamalai University. With all your permission, I wish to extend a short introduction of our session speaker with you now. It's my great honor and privilege to introduce today's esteemed chief guest and session speaker, Professor S.R. Prabhakaran sir, a distinguished academic and researcher in the field of biotechnology. Professor Prabhakaran is currently serving as a professor in the Department of Biotechnology at Ardeyar University, Coimbatore, where he has been a valued member of a faculty since 2020. His academic journey, however, began long before that with his remarkable career, including tenure as an associate professor and assistant professor in the same department. He has also contributed to the global scientific community as a visiting researcher at the University of California Santa Cruz, specializing in the microbiology and environmental toxicology. Professor Prabhakaran sir's academic qualifications are nothing short of impressive. He holds a PhD in biotechnology from Pondicherry University, and his postdoctoral research at the Center for Cellular and Molecular Biology, Hyderabad, laid the foundation for his illustrating career. Throughout his career, he has received multiple prestigious fellowships such as the IUSSF Fellowship and UCSC and Research Association from the Department of Biotechnology, Government of India. His dedication to research and education has truly made him a role model for the students and scholars alike. A prolific researcher, Professor Prabhakaran has published over 30 peer-reviewed papers and has made significant contributions to our understanding of microbial biodiversity, heavy metal resistance, and bioremediation. His work on extramorphisms and bioprocess perspectives from insect gut microbacteria and probiotic has earned him international recognitions. His research has been published in reputed journals with notable impact factors, with contributions spanning from molecular diagnostics to the study of insectical crystal proteins. His extensive research is supported by multiple funded agencies, and he has led several projects funded by DRDO, DPD, and DST. Professor Prabhakaran has also played an integral role in organizing several seminars and events, such as the National Seminars on Frontier in Biotechnology, which has brought together experts from across the globe. As a mentor, he has supervised 10 PhD students and numerous MPhil scholars, contributing to the growth of biotechnology education. His students benefit not only from his vast knowledge, but also from his passion for research and dedication to their success. Today, as we gather to listen Professor Prabhakaran sir, we are fortunate to be in the presence of someone whose work has made an incredible mark on the field of biotechnology. We are very happy to have you as a session speaker today. With all the on behalf of all the participants, I extend my warm welcome to Professor Prabhakaran sir to give a lecture under the topic of biofuels and microbes. We welcome you, sir.
Thank you, sir. Let me share the PowerPoint now.
Yes, sir. I will make use a host, sir. I will give approval, sir. Wait, sir. Yes, sir. I give an approval, sir.
Okay, I am getting ready.
Yes, sir. Yes, sir. Now you can share.
Sir, can you admit SKIC 2016, please?
Yes, sir. Which one, sir? I didn't get any approval, sir. I didn't. I didn't get any request, sir. Star Computer 2.
Yes, sir.
Yeah, yes, sir. I given, sir.
Can you admit, sir?
Yes, sir. I will, sir.
Okay, sir. Admitted.
Yes, sir.
I'll try to share this. Am I visible, sir?
Yes, sir. It's visible, sir.
Okay. Good evening, participants. Am I audible?
Yes, sir. It's clear.
Actually, I'm in a.
It's clear, sir.
Okay. So, yes. Okay. Thank you. So, I'll be taking you a small journey on biomass and biofuels. So, biofuels will be the one which can be generated from the biomass. I'll be trying to cover two aspects. One will be biofuels from the living things, especially the flora, fauna, like that. The other part, second part, will be talking about the microbes in its role. Okay, so I'll be trying to handle you the class on this particular domain. If you say biofuels, we try to start mainly as a biomass. Biomass can be a fresh one from a microbes, or many times it will be from either biological source or sometimes a derivative of that one. Say, for example, um, hydrocarbon related things or even its derivatives are regarded as input for these things. So sometimes I can even redefine something as biological waste or the waste from any unrecyclable items. So it can be either wood also, garbage in this case, maybe urban settlement will have garbage issues, and then landfill gas is another new concept, and there are very much progression in Coimbatore region. Can even add those things. Alcohol based fuels are also there, and crops mainly. Maize itself is being used, and in India they are trying to avoid biofuels originated from food items. So if it is a non-food items, it's approved. Say for example, Jetropa. Jetropa is a non-food item. So in that way, it is approved like that. So regarding the technology, whatever we are trying to use is the biomass technology. Today, it serves as many markets, and they will be developed with fossil fuels, and they will try to reduce the main use. Say, for example, the recyclable fuel, whichever in the market, those can be replaced by fossil fuels can be replaced by the recycled fuels. Industrial process, we can try to use this for several purpose. It can be either directly or indirectly used for energy generation. So industrial process means directly it is good to generate either heat or steam. So either you can use a burner, blower or something like that, or many times for steam generation it's used. So boiler is a very common thing in many industries, where boilers will be generating heat exchange through convection process. So steam itself is a very good thing. Say for example, simple industry, hotel industry, steam can is supplied for making rice, even idli, or even vegetables can be steamed before cooking. And then generally deep frying is dangerous. Steaming is always good, retaining all the good things, we could say. So electrical power generation. So it's a tricky thing. The advantage there is you can able to take the thing to the next level. I'll blow up the slide to a bigger level. So in this electrical power generation, the ease of this thing is energy can be transmitted from one place to other so easily. And then transportation fuels, so it can be collected and stored. It can be stored safely and then it can be also taken to the next level. So these are all the merits and then uses of this biomass whatever generated. The principle on this particular topic, especially generated through biomass, is the development of advanced tools like that. So, what are the technologies available, and how sugar itself can try to generate some biofuel, and thermochemical platform, it will be on a little on industrial side. Instead of that, I will try to take some biomass, biological, microbiology related things that will be in the later part of my talk. Refineries are there, so this will try to integrate all the biomass conversion and it will try to produce some fuels, and these are byproducts that will try to deliver as a fuel, energy, or even chemicals from the biomass that can be generated out of these things. So today's petrol refineries can be very well used for uh, refining the biofuel. A good example, some people can take notes like one or two words here and there so that it can try to extend your idea on this particular domain. Dechlorodesaline Incorporated. Dechlorodesaline Incorporated. You can note down this. This is a California-based startup around 10 years back. Now they are into business. An undergraduate candidate, he tied up with some NASA scientist and he started publishing some nature paper out of it. You may wonder how an undergraduate, but it is possible. Even in India, a super excited kid or collegiate can try to do or attempt those things. So what he did, whatever the brackish water, the village or urban waste that is drained, that was collected in a place and it will be generally nutrient rich, either nitrogen or potassium or one or other nutrient will be there. It was very much supplementing the nutrient for the people. So that will be used for algal generation. So algae being developed not in a reactor but in a sea, a big polythene bag which will try to collect all these things and it is being circulated for around maybe a kilometer or so. So while the entry will be the brackish water, end of the thing will be something like a crude oil like material that is almost equivalent to the what it is refinery, oil refinery, oil ore, mineral ore. So that can be used for generating like nice petroleum like products. So usually we will take this from the deep soil or terrestrial or even sea like that. But this biologically generated thing is almost finding it equivalent to the iron mineral ore or petroleum raw material. So that will be used for refineries with most of the time not big change will be there. So this is a concept developed by that group and they are trying to perform greatly and it has a high scale up value and it's going on. Sugar based platform is another domain where somebody else, you can
Sir, excuse me, sir.
Frank, tell me sir.
Sir, slides not show in your presentation, sir.
Oh, now it is not showing.
Yeah,
Now?
sir. Only, yeah.
Okay,
Now it is
so
good,
if it
sir.
is fully, I mean, presentation mode konda varla nenikiren. Now if it is okay, I can return it. Okay,
Okay, sir. Okay.
I didn't know this. Anybody else should have told. I was trying to tell blow up like that, so I can make it smaller. So now it can try to occupy.
Okay, sir.
So
Thank you.
previous slide, this you might have seen, right, sir?
Yeah, sir. Current
So
focus.
only this one. So I didn't make use of the slides, but the second point I elaborated in my theory knowledge.
Okay, okay, sir.
Okay. Thank you. So sugar platform is another thing which it will try to come in a bigger way. So all sugar refineries, they are now, they might run to uh, they might run to loss if it is so like that. But this will be very much facilitated if it is supplemented or byproduct is recycled for alcohol production. So this is the concept with which this is being presented. A biorefinery concept here. Here, generally, we are trying to produce a biomass. This can be through forest. This can be through biological material like major flora or smaller flora, or this can try to make in a larger volume, and that will be converted to heat or fuel generating technologies. So this is under the banner of biorefinery, it's coming into focus. So we can use the sugar platform by sugar generated from sugar cane, sugar beet. So in our case, in tropical countries like India, sugar-based industries, sugarcane-based industries are in plenty. But in the temperate countries, sugar beet, it's not a beetroot, but a similar tuber, that will be the source of sugar in temperate countries. So those surplus sugar or even the byproducts of sugar mill, that is molasses, that will be used for alcohol production. And alcohol per se has too much of value, and based on the residues in it, it can be either used for consumption, or I mean, there is a scope for mixing. It's called blending. It's called. It's blended with either fuel like petrol, or it's being blended with the alcoholic products. In India, the blending is permission. Blending is allowed up to 5%, and there is a scope or improvement up to 20% through these sugar-based biological refineries material. So this 20% will be a smaller volume when you and me talk, but in reality, when you try to think about for several million cubic liters or tons like that, it will be a major volume for the nation like India. So for fuel itself, it's a very big scope, but high value products can be even employed for adulteration. It's not adulteration, but blending with high value alcoholic beverages. Say for example, it's not beer or high concentrated brandy, whiskey like that and all. But those are all of very limited platform and limited scope. In country like India, it's allowed, but not in the Western world, where they try to give top priority for quality of the product, and doesn't mind the alcoholic effect. There is more than that to be considered. So, okay. So these are all possible through sugar-based business or platform. The alternate thing is the syngas or thermocoagulation platform. So this is also a similar thing, but in the upcoming slides we'll try to add more on those lines. So ultimately we are trying to use it for heat and power, or if we try to convert it as a fuel or chemical, we can use it for other alternate materials like that. So this with this concept, we'll try to proceed. If you say biofuel, biodiesel comes first, and this is made by transforming animal or vegetable fat with alcohol. And many a times in the Western world, canola, a rapeseed oil is, or even soybean or recycled restaurant grease. That means oil from generated from the kitchen that is being used for this purpose. In India, though all these things are not a major edible oil, at least soybean like edible things are banned. You should not use food purpose or food sourced material for fuel production. That means India has a large amount of subsidies that is given for agriculture sector, which is primarily meant for food or food production or even feed. But fuel is a very possibly high energy value product, which should not be, which will be a high value product, which should not be diverted. So in that case, India has a ban not to use food or feed for fuel production purposes. In this case, I can tell like it can be either jetropa like oil, or even castor oil has a much more value, or any other oil. If there is any other oil option, pungam oil is also coming into picture. But these are all like limited. There is a very high limitation in usage of all these things. And if you try to go for next, these are all directly substituted for diesel either in a neat fuel or as an oxygenated additive. Sometimes if you are trying to add this as a full substitute, that need to be changed in the engine, because there are several parameters in oil or gas or any fuel which is being injected for generating oil purposes. In this case, I would say better we should try to change the engine system itself for production of these things. So in that case, I blending up to 5 to 20%, there is no big change. So in that way they are advantageous and they are not trying to do. So this is the issue pertaining to the this one. So modified waste or even vegetable fat. So in this case, this is designed for the use of compression and ignition engines. So many times engines can be modified and then try to produce something. Production of these modified waste vegetable fat can be achieved through continuous flow of addition process. Maybe there are some type of fats which is not good for health. Say for example, dalda or vanaspati, whatever you say, it's being normally used in the place of ghee or vegetable milk fat. Uh, like melted one is ghee and butter like sometimes people try to substitute this one, and the goodness of ghee or butter won't be there in case of vanaspati, and slowly we are trying to phase out, and it's being used for some other purpose, or sometimes these commercial foods they will take advantage of these things and they will try to flavor all these things with such type of vegetable fats. So those can be a major supplement or major source for biofuels, and that can go ahead. It can be modified in many ways to make a greener form of biofuel. When it is a general or a green energy source, it has very much high advantage and a welcome attitude is available there. What is e-diesel? So if at all we are trying to blend ethanol with some uh, diesel or petro products, it's regarded as e-diesel. So these additives, they'll try to allow blending up to certain limit. Here in this case demonstration is there, blends up to 7.5 to 15% is very good. And if, as of now the government has allowed blending up to 5%, but in the days to come this number will increase. The advantage is the sugar production. Many of the sick industries, sugar mills whichever in the world, in the nation, can take this as an advantage to set up the distillery unit, and this distillery will try to get a additional income through sell of fuel from a food industry. So this is being very strictly regulated in India, and if the blending is going to increase, there is more chance that sugar industries will try to survive, and the benefit will go to the farmers. As of now, it is the hidden income for the industry, but directly the farmers are not benefited, or they are not directly harnessing the result. That's why this has to be very transparent, and if the sugar industry are trying to push it forward, we can able to harness this biofuel as a very nice input. Additives. Additives that prevent the ethanol and diesel from separating well out. There are some physical parameters they will try to, in fact, say for example, water contamination, if it is there in alcohol, that will be a big menace for the engine. So we should try to make it as an absolute alcohol, and absolute alcohol means 99.99, even 100%. But Alcohol itself is hygroscopic. We can try to have a handful of petrol in your hand, it will try to evaporate, but alcohol will try to rehydrate. That means if you try to pour 100 ml of absolute alcohol, in 10 minutes it will become 110 ml. Means it will try to rehydrate water into it, and then they will try to increase in volume. This increase in volume upon exposure to outside air will try to give some problem. Let me take some water. Jetropa. So this is a very good source. So Jetropa can be very well supplemented or very much used as a biodiesel source for nation. Seeds of the Jetropa nut is crushed and oil is extracted. It is not an edible oil. This oil is processed and ultimately it is refined to a form of biodiesel. And process for this is come up a decade ago in a bigger way, though it didn't pick up, but still there is a potential for development of Jetropa based oil. Gaseous fuel. So how gaseous fuel will try to supplement the thing. So in this case, gas fuel technology will try to contribute for a greener nation very easily by means of several sub, sub subcom several supplementary things. So in this case, I could try to tell about the gobar gas or the biogas, even synthesized gas, syngene gas, and also is the term available for this particular technology. And just see about these things in the upcoming slides. Gasification. So biomass gasification is the full term where the process try to use heat and pressure to generate steam and also convert all the material to a gas that will be composed of carbon monoxide and hydrogen. So there are several industries in Coimbatore who try to generate electricity from bio waste. So these industries are sick now because of the subsidies that are cut by the government, and the energy tariff whichever the government is giving is not matching with the industrialist. And for several years, things are going on to bridge the gap, but very highly established systems are now kept idle because of some government issues. This has to be taken care by the government to rely or to take it forward in a greater way. So apart from the political and the reality scenario, let's learn about the theory behind this particular technology. Will rely on four factors, mostly engineering factors. The gasification reactor atmosphere. So this is a level of oxygen and air content that will be regulated in a system that will try to allow the energy conversion that is happen in the thing. So also the design of the reactor should be so ideal so that there will be high energy conversion happening. And also the internal external heating, because internal heating can be converted into energy, but external heating sometimes it will be dissipated. So more the energy loss that is curtailed or saved will be the energy product produced. Even the operating temperature. I was visiting one such biomass gasification plant in Pollachi region. Operating temperature is a very serious issue. That means either the surrounding climate or even the temperature of the serious surroundings. Say, for example, summer it will be good, and winter or rainy season it will be sick. So that is also a major concern. One good thing I learned from them is that we can we can collect the gas, and we will try to put a chimney and then send the gas out. And while gas is being allowed to go into the upper atmosphere also, there are some factors considered. We learned lot of theory, but in practical when I went, I said, why not we try to tap the entire energy and then allow to exhaust, sir. If I ask like that, one owner or he is the operator of the chief gasification plant, he told there need to be high temperature even in the gas that is exit. The sense hot air goes up, it should not come down and then give problem for the area that is surrounding the particular region. So that was the serious concern which the person was trying to exhibit. In that case, while the gas is being exhausted, at least 50 degrees should be there, even 70 degree he said. That's why is 100 feet chimney will try to blow further gas to another 200 300 feet above, so that local warmth won't be felt if it is blown to the upper atmosphere, and that can happen only if the gas is forcefully sent out and then made it lighter so that it won't come back bound to the industry area or surrounding area. These are small add-ons I can give, based on my theory knowledge, I mean practical knowledge. So what are all the things that are being used as a raw material for glassification? Here you can see coal, petroleum based material. Coal means the NLC, National Navy Lignite Corporation. So they use the lignite, a third grade mm, coal for this purpose. They also try to generate lot of heat, and for greener economy or greener India or greener nation, to avoid climate change. These are all not a good alternate. So the UN has formulated SDG goals, 17 SDG goals. All students and the general public also should know what is the SDG goal of UN recommended for entire nation like that. Even in your syllabus, soon there will be introduction of SDG. And one among the category is the indigenous knowledge system that is being educated through Bharatiya University to incorporate in the syllabus of the future generation. If at all today you don't have an IKS in knowledge in your syllabus like that, next semester, next year onwards, students will be joining and they will be talking about IKS, because this particular domain is very limited and many people know. And Bharatiya University going to organize a training workshop. I mean, from March 10th for teachers, and through UGC this is being operated. If not this year, some of your college staff also will attend that one, and they will try to incorporate the IKS in your syllabus. So keeping those things aside, the coal based or petroleum based is not a sustainable one. Okay, SDG goal is sustainable development goals, SDG. So these two are not sustainable, and we are going to concentrate on organic materials. Organic means it can be anything. So, for example, next it should be a prepared one, fed and dry or slurried form, and sealed reactor chamber called gasifier. So it's a general notation given for all inputs. But in my opinion, I would say organic material means thrashes, wood, roots, bagasse, even the thorns or whatever sholas or whatever leaves, fronds, whatever agro or forestry wood based, all can be used as a raw material. The feedstock is prepared and then fed to the gasifier, as we have seen. The seed stock is being subjected to high heat and pressure, either oxygen rich or oxygen starved environment within the gasifier. This is being harnessed for the energy production. So here you can see in the demonstration raw materials such as charcoal, even wood pieces, and the sawdust cubes, and the wood chips, all are waste in the timber industry or agriculture industry. Those can be used for this purpose. So gasification can happen in three or four ways, and then the products obtained are also classified into hydrocarbon gas called as N gas, and then hydrocarbon liquids such as oils, and also a char. Char is nothing but some black color solution or ash material which will have some nutrient value. Syngas is the one basically carbon monoxide and hydrogen. About contribution of these things will be up to 85%, but small amount of CO2 and methane is there, and this try to convert or try to provide as a gas system. So, if we try to talk about the gasifier plant, this is a small flow chart. A gasifier will be there, and it will be purified, and there will be combustion engine, internal combustion engine, and then this will try to feed into the generator to generate electricity, and a miniature of a gas plant can be fit in vehicles, and these vehicles can try to operate an engine, and there will mobile vehicles can be done. And if it is in a static things, we can even feed directly these things instead of producing electricity to machines, because for each and every add-on, scale up, step up process and step down process, there will be energy loss that can be very well harnessed if it is directly used in the machine. Say for example, we try to use solar heaters. So solar material will be directly converted into water heating drinks and then come to your doorstep. Rather, there are solar panels. So through solar panel, if you can generate electricity, and then if you try to ignite a heater coil, and then you try to geyser produce the water, then there will be a huge energy loss. Either it can be conversion, generation of electricity itself is costly. Photovoltaic cells, that itself is 70 to 80% efficiency, whatever we have in market. Apart from that, production center and the consumption center will try to, the current has to carry from meters to kilometers. So there will be energy loss due to resistance. And then if you try to take the coil, heating coil, that also will be star rated. You can see in the refrigerator, a small star, 5 star will be there, and 4 star rating, 3 star rating, 5 star rating will be there. Nowadays, all the energy consuming equipments will have all these things, so you can see the rating there. So there is energy loss in step up and step down protocols. So in that case, if you are trying to use the gasifier plant directly to the machine, you will be harnessing highest energy loss, without energy loss. 90% will go as an energy. If the first, second, third, first part has some two or three demerit, the other will harness in a better way. The best advantage or unique advantage in the first thing is we can carry the energy from one part of the world to the other part of the nation. Say for example, windmills are there. That is also an eco energy plant. So a company who has windmill in our Dharapuram or Nilgiri area along the Palghat gap, they can collect and then give it to the central grid. Okay, power grid will be there. There are four power grids in India: north, south, east, west, like that. These people will try to give in the central power grid, either in southern region, and they can harness and take in the northern region. Say for example, eastern side, northeastern hill, Guwahati, Gorakhpur, these regions are industrially sick places. These generally established new companies will go there, establish there. There they will try to harness the electricity for free. So production of electricity in southern region and harnessing it for free in the northern or eastern region is a very big merit for the industry. So that merit always this electricity has. But you can see the fun in all the three. We cannot store the energy in a liquid form. That is the biggest disadvantage I could recall in the gasifier plant. A typical gasifier plant is given here. It's an engineering diagram. You will be more knowing better than me. I am basically a biologist and agriculturist. So reactor is there. There is a cleaner or cooler, something like that. You can try to see the gas washer, dryer. So this will try to remove the moisture excellently, and then it will try to go and then feed to the engine. In between, there are some cooling systems that is required, that is done, and power production is done, or even the heat is directly taken as an energy for boilers and other things. If it is electricity, it can go to the power grid. This is how the system works. And cogen is the term used for biogas gasifying system. A good cogen which you can also visit. You are from Gopi, I know. Your nearest place is Apakudal. There is a sugar mill called Sakti Sugars. They allow the students to visit their plant. They have a cogen plant for energy generation, and that is generated, I think, through Bagasi. They generate electricity and give to the grid. Bagasi is nothing but the sugar mill waste. It is used for production of paper also. So there is a Karur based paper mills. TNPL is a very elite power um, paper mill among the star companies of the state, Tamil Nadu. So they use large bagasse for their paper production, and they take sugar mill waste bagasse, and in turn they give equivalent amount of coal to that industry. These are all some practical points. When you really visit the place, you can learn, and they give sufficiently permission. You can think about it. Okay, cogen will be a very big, huge thing where engineering candidates can go and learn a lot. But the input there is biological material. Many times it is bagasse, but it can be coal also. In many cases, they will try to use the byproduct of alcohol industry also there. But Apakodal, I believe it is a bagasse based. So gasifiers, I am going to reduce and then try to skip something because my part on biology is pending. So you can see here, air is getting blown, oxidation is going to happen, and there is a process called pyrolysis. Wherever you try to talk about gasifiers or cogen, you will be learning about the term pyrolysis. Go through the definition in your theory, and they will try to give a gas, and when fuel is being pumped in. So this is called a updraft gasifier. So I'm also learning along with you. So I'm not an expert here. So downdraft gasifier, downdraft gasifier. In this case, you can see, you can imagine the gas is being sent out in the bottom. Okay, that should be a complicated engineering behind this. My concern is only the fuel and gas, and engineering people, you take the best for that is also twin, where the air is being fed in the sidewards and the middle gas is being taken. You can see here the input for this is wood, and then ash is being extracted. In between there is a gas that is being used as a fuel. So, cross draft gas producers. So, in this case, pyrolysis happen in one place, and the heat is being employed for drying of the material also. Then the reduction will try to supply some gas that is being used as an energy here. Gobar gas. And this is where the microbiology comes into picture. Gobar gas is nothing but a process called anaerobic digestion, and through this digestion, instead of a heat producing carbon dioxide, we'll be getting a methane. Methane is a biogas that can be used as a fuel in the place of LPG. LPG means liquid petroleum gas, which contain butane. And you may wonder why butane is smelling like that. But in reality, butane doesn't have any smell. But a gas leakage should be detected by people, so they will add one more polymer or bioproduct, petroleum product, that will try to give some smell. So that butane doesn't have any smell. That is the take-home message it should learn. Similar to that, methane is also there. Methane will have a light pungent smell, but while it is lit for fire, this smell won't come. But as a separate thing, methane has a small, stinky smell. A gas leak alone will try to give a stinky smell. A burnt gas won't give because it will become carbon dioxide or even little monoxide. It doesn't have any great smell or something like that. So this is an anaerobic process. So whatever the biology which we learn, aerobes, we know good number of bacteria that will be produced consuming oxygen and trying to give us aerobe. But in this case, anaerobe. In the absence of oxygen, this gobar gas is being produced. So this is nothing but fermentation that is carried out in an airtight controlled condition. So this can be either in a cylindrical concrete tank or any globule, any glass material, whatever it is, it's possible. They will try to create an anaerobic environment and it will be used as a gas or something else. How it is produced? So gobar gas is a very classical term. It is being produced or genesis is from India. A biologist, a veterinarian, when he was slaughtering or dissecting a cow, it he came across a bolt. Bolt means blotted. Vairu uppana mari. So blotted intestine or gut. So he was wondering why the gut is so much bloated. So when he was trying to pierce through something like injection syringe or needle like that, the gas was releasing with a heavy pressure, and he happened to observe that it was having some flammable option. So he was able to produce gas from the cow dung that is being secreted in the intestine or stomach of the cow. So thereafter, the gobar gas was invented or discovered, you should say. So this was made into business, or this was made into industry in a in vivo in vitro, like outside environment. So in this case only this biologically production of gas came into picture, and this particular gas has come up. A classical system of gobar gas consists of a system like this, where the dung gobar is nothing but, I think, Hindi word. 1 minute. Sorry. Continuous talk. I took some water. So the gobar gas is being fed as a slurry into a compost tank. So compost tank is nothing but a closed tank, anaerobic, no oxygen exposure is there, and they will try to stay for 15 days, and they will try to form a system called scum. This scum is rich in anaerobes, especially methane producing methanogens, methanosarcina, and a lot many things will try to accumulate there. And the anaerobic science itself developed based on this, and this is what trying to develop some gas. This gas ultimately will try to give a positive pressure, and this gas will give a pressure towards down, and it will try to either give a pressure gas outside, or it will try to push some of the waste of the composted one as an outlet. This outlet will come as a highly digested cow dung slurry as a manure, which can be directly used as a fertilizer. This can be also fed as a feed for vermicompost, or it can be fed into the agriculture channel along the water also. So it's a rich manure free of weed seeds or even immature or partially digested cow dung or any organic matter. So it's the gas. If you try to take the gas, it is being used as a direct cooking gas, or especially for lighting. So most people will know about Petromax light. So nowadays it is being replaced by electric things, but still Petromax light has an advantage. A gentle purge of the gas or aerosol of fuel will try to light a mantle which will be super bright compared to the ordinary flame. So this type of lighting can be done through means of this gobar gas, and cooking can be done directly. But there is a reservation by people. Social stigma is there. How dung waste gas can be used for cooking. So for this purpose, many of the hostels and hotels, they try to generate steam, and they use the steam for some other purposes. Addition, in addition to the gobar gas are good thing, Instead of a cattle dung, even human waste can be connected. Sometimes human toilet, that is septic tank waste, can be fed to that. That will go as a slurry and come. No advent. No, we can try to avoid two things. One is the slurry of the sewage septic tank can be avoided. One reason. Another thing, it can be ordered also with pulverized food waste and vegetable waste generated in a hotel or a kitchen. Some of the hostels in Coimbatore has this gobar gas facility where they try to reduce among the gas consumption up to 10%. The maintenance of these things will be in a few thousand, hardly a labor meant for cutting, chopping, grinding, and then pulverizing and feeding the material, which can try to give out 3 to 4 times the expense of scent. So it is more sustainable and it is going to give you a manure. When you calculate the amount of waste generated and manpower consumed, the gas which is generated for lighting or cooking purpose and the manure will be definitely highly incomparable. So it's a part of sustainable goals, and many times NAC or NARF is looking for such active biogas plants across the institutions. Many times it goes by paper, and if it is made it as a rule, or if it is made as a usage, it will have a very big advantage. So there are several engineering models marvels in this particular domain, and too many things are in force. Like we can try to purchase a gas plant from 5 liter to even up to 300, or even up to a village. We can try to take like several thousand cubic meter gallons like that. Before forgetting, I wish to learn or try to tell. We are trying to have LPG gas in a compressed nation, liquid petroleum gas. That means it's a compressed gas, or even we can say it as a CNG. CNG is another name, another form of it, used for vehicles, compressed natural gas. So once compression happens, it will get liquefied. But this methane cannot be liquefied, and several research is happening to convert into sun or other form to that liquefaction has happen. But it's not so easy to do that. So many times there is a lot of issues to liquefy or try to make the gas in a handy and mobile form. The merit or these things, this is can be easily carried. So I know in Pakistan I saw a movie or even a documentary where people are collecting in a polythene bag. Say for example, you might be knowing the puffed rice, pori sola pori mari puffed gas, or you can see popcorn, it will be like a thermocol. So they will take a very big polythene which is used for garbage disposal. Say for example, your garbage will be disposed by smart people in the name of modernity in a black polythene. So such a polythene bag is collected, and this gas are collected in huge volume in a polythene. So people are trying to take it and then try to connect in a gas and then use for daily whole purpose like this. Poor people who can't afford LPG, they are collecting this and then walking along the roads. You can Google it for images. It will be a funny but dangerous village. You cannot give guarantee if there are inflammable issues and all. If an accident happen, it will be very very traumatic, where there is a loss of life possible due to the polythene gas. But it is handy. So likewise, we can even take gobar gas for carrying and then disposing in a lighting in a gas lighting area or something. The merit over there is it's a cheaper one, and daily we can collect the. So in India also, some people will try to pressure and then try to store in cycle tubes or vehicle tubes. Car tubes are cheaper if it is a tube type tire, cup tire like that. Even inflated one can be puncture, can be fixed, and this compressed methane gas can be flooded into the tire tubes, and then it can be regulated and relatively safely handled for this purpose. but several things are going on in this line. So what you are seeing here is called the KVIC model. The Khadi and Village Industries Corporation, they made their own model where a tank of intake will be there below the ground level. They make a valve and then they'll try to make a gas. So in this case, a floating cylinder won't be there. The pressure will still be there, and you can see the constriction. There will be input and output covered or constricted by a wall. So highly digested slurry alone will try to go up, release the gas, and then come down for exit. And this is a very nice, easy system. It can do it below the ground also. So what are the solids which will try to form a biofuel like that? If you try to compare, the solids will be accounting from wood chips to several biological origin. So what are those? We'll try to see. So wood, domestic heating is done in wood by some of the bioenergy market. Like in India, we don't need a burner or a blower for heating the house. But in the Western world, where it is snow capped or full of snow, the house should be heated by some one or other energy. So many times they will try to make cause of wood, and the problem is in a closed system, wood will try to consume lot of oxygen. So oxygen deprived environment will be there in the wood or chimney, whichever we are trying to use it. But still, traditional people they will try to make a fire with this to heat the region. Nowadays, electric and gas-based heating systems are very common in Western world. So there are improvements in this technology where it is trying to be equipped for energy efficient heating equipment. It all going to happen. So they are trying to make some tiled stoves and also boilers, wood chip boilers, pellet stoves. They are trying to make it as a chips and small sliced thing, pellet it, and then they are going to make it handy. So in India, we are trying to cut the casuarina and make it into a small wooden log handy for burning. So like that, they will try to make a briquettes or even small beads like thing, which can be hardly in the size of a few centimeter or like sticks. So this will be very easy to handle to incorporate everything. So people are even trying to convert this into a pourable wood-based fuel. That means they can try to make a slurry and then pour. So for carrying or compaction, that will be very much helping. So wood chip boilers will look like this. They are going to feed in one place and they will try to burn, and they are going to generate either steam, many times steam, otherwise gas also, and will try to go. So why your mentor Ramlingam sir or Tirunjanan Samban sir took this title for a lecture to you is, we are concerned about the environment first. The Ministry of Environment Forest is now renamed or called as Ministry of Environment, Forest and Climate Change. That means the importance of climate change you will be knowing. There is a saying or even conservation of CBD, conservation of biological diversity. So this particular CBD dictates about the reduction of carbon emissions by each and every country to reduce the air pollution, soil deterioration, ultimately global warming. So these technologies will try to avoid or reduce the air pollution, and soil deterioration. Obviously, whatever the waste we are throwing out will be a soil deterioration. Say for example, coal based industrial waste will try to throw the fly ash. Nowadays fly ash is being added into the bricks, precast bricks as an ingredient, and that is being encouraged by the government by giving a subsidy. Or if you are trying to make a brick with fly ash, you will be exempted from tax, or you will be getting generation. So soil deterioration is being generated, is reduced by means of all these things. So air concerns, biomass produced by this technology will have reduced emission, and ozone depletion will try to reduce. So all these nitrous oxide emissions can be kept under control. So many times inhalation of ethanol is fuel. So for fun sake, we used to make tease our friends just by smelling alcohol. You are being addicted or you are making fatigue like that. But in reality, excessive inhalation of ethanol itself is harmful. Our metabolic process or the respiratory system won't digest it and then trying to convert into a proper one. So combustion of ethanol is going to release some atmospheric high concentration of carcinogens. Carcinogens, any chemical which is going to cause cancer is called carcinogen. So this type of combustion fuel from ethanol based industry also will try to give some issues. So when it is hydrocarbon based, we cannot imagine monoxides will increase, and ultimately increase of all these carbon dioxide will try to reduce the increase the risk of carbon dioxide content, and thereby the ozone depletion or ozone holes or ஓட்டைகள் சொல்லுவாங்க ozone ஓட்டைகள், they will try to allow the extraneous energy radiations into the earth, and there is no scope for escape of those things. The very good condition of earth to have habituated by flora and fauna is because of the ideal temperature maintained in earth. So this will shoot up, and we'll be experiencing high temperature in the nation, and due to this global warming lot many harmful things happen. Say for example, the Arctic or Antarctic, there will be a huge melt of ice. Even in the snow caps mountains of Himalayas and several western world, they will try to melt. There will be a huge increase in sea level, because a continent, if it is going to melt like Antarctica, those give water like anything, which will try to make some of the cities sink. Days to come, even Chennai will be under threat, especially the Karaikal area, Kodiyakkarai, where Cape, some Kodiyakkarai is called a low-lying area, marshy lands. They will go into the seawater, and that is a threat or warning alarmed by the UN or even the concern about the environmentalists. A country by name Maldives may go into water, and they demonstrated this through a parliamentary committee where all the MPs were wearing the scuba diving suit and go into the water to conduct their meeting. So this will be the state fate of the country, like that they were trying to get alarmed. So increased temperature will also bring some lot of risk. Even the attitude of Coimbatore people never be so angry like a Chennai person. So Chennai, due to temperature, people will get very easily angry due to the sultriness. But in Coimbatore, people will be so polite. Never they will be using the vulgar words or angry like that, because of the temperature and relative humidity, which is very much compromised. You won't get so easily frustrated with the situation. So the environment also will bring such a change, and these are all the indirect effect of the global warming. So I am trying to connect with the region and then try to give a flavor of a thought, just to you can take it home. And the character of our own region, Coimbatore, Kongu region, or Gobi, Chettipalayam, all come under same things. The thing is, the lower temperature will try to make you cool mentally, physically, physiologically, whatever it is. Last point, emission of relatively large size particulate matter. These things will try to give some particulate matter where it will try to block the respiratory chain. In Coimbatore, being a textile town, many people won't stay long because of the fibers that are generated from the cotton mills or yarn mills who are trying to make some hand with the flint or the cotton things. So now cotton mills have moved to the peripheral region like Erode or Tirupur, but people in Coimbatore are having a threat in those days for this one. Now another thing came into picture, the railweed or the Parthenium. Those pollen also is giving threat like asthma for many people. But here, these industries will try to give particulate matter of larger size that will be of environmental concern. Burning, sir, organizer, how long I can handle? Is there any question session? May I know? Hello, sir. Organizers, the session is up to what time? Any participant can tell?
It's till 7:30.
7:30. Now the time is 7:05. Maybe in 10-15 minutes I'll wind up, ma'am. Thank you. So now, soil concerns. Burning biomass will deprive local ecosystem of nutrients. So definitely, the concern of the burning biomass is a major thing. First example I'll say about the sugar mill. Sugar mills, after harvesting sugar cane, the thrashes will be burnt, and this, if it is converted as manure, it will try to give lot of good things. Rather, it can be inferred as a fuel for biomass gasification. You can try to avoid whatever the burnt energy in the field. The energy can be tapped as energy, usable energy in a biomass gasification. So on contrary, you can turn about the bad things of biomass in Punjab region. The Punjab region wheat, whichever burnt in the Punjab region, comes like a cloud that comes and then blocks the relative humidity of Delhi. The whole airport is under threat for 2-3 months because of the burned biomass of Punjab. Imagine if a biomass plant is being established there, they can be made into energy, and also the threat of threatening international cargo and airline movement can be put on hold due to avoiding those things. So apart from that, this particular slide is going to talk about the soil concerns. So they will try to spoil the microbes of the soil, especially the rhizosphere soil. So production of dedicated energy crops renders this land fallow also. So the fallow land will try to create lot of nuisance like heat generation, microbial depletion, and nutrient loss, everything. So burning also will try to reduce the land available for cattle grazing. So they are trying to avoid this. Then increased pesticide and fertilizers will try to produce energy crops that contaminate the ground and surface water. Down the lane, it will try to even affect the aquatic habitat and wildlife. Environmental benefits, all these biomass can be converted into energy. So waste presence around will be reduced. Low emission of greenhouse gases. All the dangerous gases will be converted to either syngas or any form of fuels compared to the fuels that is produced through fossils like petrol, diesel, CNG, LPG. This will try to reduce the greenhouse gases. Ethanol is a carbon neutral form. That means whatever you convert as ethanol is a very big thing for carbon. So we are going to reduce it, thereby reducing the carbon accumulation in the environment. So in a carbon cycle, alcohol plays a very major role. Growing variety of crops will try to increase biodiversity. Of course, it's going to happen. Socio-economic benefits. So country will come to a boon. This help to develop the economy of the country based with agrarian community. That means agriculture-based inputs can be very much improved by means of harnessing more energy. So increase jobs. So this will try to generate a smart job instead of a classical agriculture lab. So this will increase trade balance. Say Indian perspective, there is lesser scope for foreign resources. We are trying to look for Gulf countries, and even for getting fuel, we compromise a lot with the several nations. We are being creating enmity with others also. Though there are some Indian-based production for petrol, we largely depend on Western or Saudi Arabian countries for fuel. That can be dependence can be almost reduced. So, what is the situation of the world? We'll see this and then wind up for today's session. Brazil is the biggest producer of ethanol because they produce sugarcane like anything. They produce like equivalent to 2 lakh barrels of gasoline through ethanol itself. They blend up to 24% in the vehicles there. Less competitiveness is there. Biodiesel is being improved in each and every country, that is making in a bigger way. So instead of purchasing petrol in the days to come, we will try to import ethanol. That is possible. USA consumes large amount of gas based products. They call it as gas. Even the petrol is regarded there as a gas. So they try to apply and try to sell ethanol blends up to 15%, and they are being employed there. The production of these things are aimed somewhere around 4.5 billion. These statistics can be there. So all these biological based thing is being removed, and they mainly trust for soybean. So unlike Indian company, those people will try to produce soybean food based thing is there in market. So unlike the Indian company, they don't mind, they use this one. European, the largest source for them is rapeseed, and they are blending up to 15% from 3%. And among the EU itself, you can see some of the countries give some advantage. Like France is going to give exemption for domestic tax if they try to use a blended petrol or fuel. So in Germany, sale of biodiesel is coming to so much of gallons. Okay, so these type of fuels are in constant increase. Other countries like China, they produce ethanol and they rank third in the world, and extra they even produce extra amount for export purpose. In Southeast, Jatropha is the one which is significant fuel for the purpose. Malaysia, Indonesia, they start pilot scale production from palm oil. Palm oil is very much excess there. They produce in large and they will try to consume for food, and also they are making the surplus one which cannot be exported for energy production. In India, basically we have sugarcane, molasses, and agriculture waste for ethanol production or even biomass gasification. A nice network of sugarcane industries is in force. They will produce largely molasses. They through gasi or molasses, they will try to produce ethanol directly or energy through cogen process. Agricultural waste based energy production company is also in force. They try to produce like their cost is somewhere around 18 liters per liter in these methods. The thing is, even like petrol, where around 35% of our price is being levied as a tax, like 28% happening maximum for your luxury tax through the current government regime GST. So this doesn't come, fuel count doesn't come under GST, but 18 liter is a very compromised price, over which if tax subsidies are levied, we can reduce the cost of fuel whichever you are going to use. There is a scope up to annual production of up to 1.5 billion, which is a very good volume. So we totally expand on Jetropa. Honge, another one which I am not aware. Anyhow, you can Google and check it out. We are in the fake end of the presentation. So high capital cost, broad scale production need to be initiated, and the cost of thing without these projects is coming to around 27. That means the establishment cost, everything counts. That's why. So whatever you produce as a plate in your laboratory or practical, if it is going to be 10 rupees, the established lab charges electricity, professor, faculty, purchase protocol, supplies, everything will try to add. That's why though the cost of production material to matter costs around 18, the established structures, its cost like asset creation, facility, maintenance, electricity, water charge, all will try to add, and somewhere it's around 27, which is still a compromised number. So biomass, this supplies up to 14% of world energy production, and on an average, biomass produced around 38% as a primary energy in developing countries. We are falling under developing countries still. There is a potential up to so much, but we are still up to 14 level. So developed nations like USA, they are trying to produce like 4% alone from this part of this like thing. India is very much short of so much of energy, 15,000 megawatts, and it costs about like 25,000 crores. This can be very well bridged by the government by reducing the annual import of oil. This biomass from cattle manure is sold is very huge. Agricultural waste, forest residues, municipal waste, all comes to a menace for the government or agrarian community to handle. If those things are properly handled, we can try to reduce the greenhouse gases and make them into an productive energy. The anaerobic digestion of livestock waste can give lot of biomass. Each and every household doesn't need a NPG connection. They can happily satisfy with the biological material. So these digester consume roughly one third of the power in its capable production, and so we can save the two third as a material. And obviously, all these products will try to give fertilizer as a byproduct, which is an input. So average we are trying to consume like generate like 5.5 kilowatt per cow. So electricity we consider only milk as a product or cow urine as a product. Now we can imagine the same can be generated as a electricity at your home. Imagine each and every cow producing so much. A nice cartoon conclude this presentation. These biofuels work better, and especially after adding the gasoline. So that's what the person says. You can see the small biogas plant fitted on this tractor. They call it as renewable energy vehicle. So with the funny cartoon, I try to conclude the things. I welcome questions for this one from the audience. So I'm signing off. So I can enable escape.
Sir, sir,
Yes, sir.
sir, just 1 minute, sir. If you're closed your presentation, means our entire session will be closed. I just
Okay.
remove your ghost, sir. Just 1 minute, sir.
Yes, sir.
Yes. Yes, sir, I removed. Participants, if you have any doubt, if you have any interaction with our guest speaker,
Any questions? You can text me.
participant, anybody want to
Yeah, I
interact
have
with
a
guest?
question.
Yeah.
Go
Yes,
I
ahead,
ma'am.
have a
madam.
question, sir.
Yes, ma'am. Yes, ma'am. You carry on.
Go ahead, madam.
Yeah, okay. It was very interesting to see your presentation on molasses and, how they are converting to biofuels and what are the things being done to generate electricity in Coimbatore, for example, and
Okay.
Shakti sugars and all that. I have a question for you.
Go ahead, ma'am.
Basically, the carbon emissions, I mean, especially methane, comes from cattle, right? A lot of the, methane actually comes from cattle. Is
Yes.
there any concerted effort to capture the methane from cattle and generate biogas from that? Because, as I understand, 48% of the global methane emissions are from Indian cattle. And I read some huge numbers of the gas that are produced annually from our cattle.
Yes, ma'am.
So, is there any study done on this? And I know it sounds funny. And I know that most of the gas actually is due to belching of the cattle. But has there been any concerted effort in this area?
Ma'am, I am a subsidiary user of biogas, and I try to learn this from a person called Dr. Kamaraj, who is a professor of bioenergy in Agriculture University. So there is a NGO by name NERD, NERD,
They're
NERD,
based in Coimbatore?
faculty in Agriculture University, now retired, and he has his own NGO called NERD, NERD.
Okay, okay,
So he should be the best person to enlighten you on this particular aspect. As a faculty who is more concerned with the environment, I could say the cost involved in biogas is manual labor and other things is not much lucrative. So I am the person in charge for establishing a gobar glass plant in Bharatiya University. I
okay,
established with the same person for the cost of around 3 lakhs, and I handed over the thing to the administration or hostels to mix
okay.
and then feed the thing with either food waste or the vegetable waste. No
Right,
labor come forward. Though I say there is a substantial reduce in cost and I can ready to pay labor for it, the dirty job is not appreciated by the people. The system after establishment stays idle. First point.
right, right. Yeah, I
Second
know
point.
of one place in Coimbatore where such a system exists but is not operational. Yeah,
True, true. Even for spraying or putting some cow dung on the house front, they use a dye, சாணி பவுடர் எல்லாருக்கும் தெரியும். யாருமே சாணி
correctly.
இல்லாத ஊர்ல இருக்கிற மாதிரி சாணி பவுடர் போட்டு பூசுற ஊர் நாம.
Hmm.
Other way
Right,
I should
right.
say the stigma of acceptance of gobar gas or gas generated from cow dung or even human waste not accepted by people for cooking or something. So obviously the urgent need is we should remove that stigma attached to the source of the energy or flame that is coming out from there. So that is a
It's
major
a
concern.
classic communication issue.
True, ma'am. So that is a major problem we encounter or we counterfeit with the gobar gas production.
Okay,
Yeah,
interesting.
you can contact Nerd Society, Professor Kamraj. He is in very much into society to learn
Okay,
something more on gobar gas and even statistics scenario, ma'am. He is a very good professor.
okay,
If you write to
okay,
me, if you write to me in the same email ID, I can even share some of his presentations, which will be very,
okay,
very educative.
okay. All right. Thank you so much. I will do that.
Thank you, ma'am.
Participants, you have any other questions?
Good evening, sir.
Please
Good
go
evening,
ahead.
sir. You are audible.
Sir, it was a very nice presentation and topic was very good.
Thank you.
We have to know many unknown things from this PPT. Sir, I have a question that if we have generated the gobar gas or biogas, how can
Okay.
we convert into electricity? There is any direct mechanism to convert it or a special machine for that? How can we convert electricity from gobar gas? Can you elaborate the sir?
Okay, so I'm at a presented in my presentation at the gobar gas, whatever you are going to produce, that can be used for three purposes. The first one in the line is electricity, which is through some generator. So your case is how it can operate a machine, correct, sir?
Yes, sir.
So this has some modification, and for generator itself they will try to use the same thing like generator directly refers to electricity, I mean heat energy to electrical energy. Machines will receive this gas input and there is a modification in the engine, sir. And I had seen such an engine operational in agriculture university. I am from agriculture, and the College of Engineering has a prototype modules, and they will try to inject this gas itself as a feed input. So combustion engine will try to spark flame, and they will try to generate. And direct usage of this gobar gas needs some modification. Say for example, in this case, I didn't use it for a flame purpose. Say for example, gobar gas is not being used for uh, stove purpose. So in this gobar gas, the modification is a very critical part which need to be taken care by the mechanical engineering people. I don't know the perfect science behind it, engineering behind it, but a small modification, even the LPG burner won't work good for gobar gas. The gobar gas need a very large dia flame, and the flame won't be so, I mean, heat transfer coefficient won't be very much high. They say it as latent heat or blue flame like that. So flame quality won't be so great like LPG, but a compromised one. And for that one also, even to flame it, we need a unique burner. This is what my explanation pertaining to your question, sir.
Thank you, sir.
Thank you.
Thank you, sir. Participant, you want any other interaction? Okay. Participant, do you want any other interaction with guest speaker? Okay, thank you. Now I invite Ms. Aswini, Assistant Professor, to deliver the keynote of session.
Thank you for exploring the significance of biomass and biofuels in sustainable energy, sir. Thank you so much for your valuable insights. The summary of this session is biomass and biofuels are renewable energy sources derived from organic materials such as plants, agricultural waste, and algae. Biomass can be directly burned for heat or converted into biofuels and biodiesel. This energy sources reduces dependence on fossil fuel, lower greenhouse gas emissions, and contribute to sustainable energy solutions. However, challenges like land use, food security, and energy conversion efficiency need to be addressed for wider adoption. Thank you once again for this opportunity. Thank you to one and all.
Thank you, ma'am. Thank you, ma'am. Now I invite Reshma ma'am, Professor, English Department, to deliver the vote of thanks.
Thank you. And maybe you can switch off the audio, Sri Venkateswara, organizer Sambandam probably. I get an echo.
Sir, actually,
Thanks.
okay.
Am I audible?
Ma'am, Reshma ma'am. Yes, ma'am. Yes,
Am
ma'am.
I audible, sir?
You continue.
Yes,
Yes,
sir.
ma'am.
Yes, sir. Okay, sir. Good evening, everyone. On behalf of the management of Sri Venkateswara High Tech Engineering College and the participants of the fourth day session of 8th session of this Atal FDP program, I wish to convey my extreme gratitude to the resource person of this session, Dr. S.R. Prabhakaran, Professor, Center of Biotechnology, Annamalai University, for taking the time to share your expertise with us. Your presentation on the topic of biofuels and microbes was really informative and engaging, and we appreciated your willingness to answer our gratitude questions. Thanks for being such a great resource. Once again, we thank you, sir. Thank you so much.
Thank you, ma'am. Sir Prabhakaran sir, our next session expert Madhoni sir also joined, sir. If you are wish, if you are continue in this program, sir, unless otherwise you can leave. There was no issues in that. Sir, Dr. Ashok Madhoni sir, shall we start, sir?
Yes, I am ready. We
Yes,
can
sir.
start.
Okay, sir. Now I invite
Can
Reshma
I sign off,
ma'am.
please?
Yes, sir, you can.
Thank you.
Thank you so
Thank
much,
you,
sir.
all
Thank
of
you so
you.
much.
Bye bye.
Thank you, sir. Reshma ma'am, now you can continue the chief guest introduction for this session.
Yeah, okay, sir. Sure. Good evening, all. I'm very grateful for giving me this opportunity to welcome you all to the fourth day, eighth section of the Atal FDP Faculty Development Program. On behalf of the management of SVHEZ and the participants of this session, I wholeheartedly welcome a resource person, Dr. Ashok G. Matani, whose remarkable academic and professional contributions have left an indelible mark on the field of mechanical engineering. Dr. Matani is a professor in the Department of Mechanical Engineering at the Government College of Engineering, Jalgan, Maharashtra, where he has dedicated over 3 decades to shaping the minds of future engineers. With an educational background, this includes a PhD in mechanical engineering. Dr. Matani's career spans 33 years, encompassing a diverse range of roles in academic, research, administration, and industry. His expertise is wide-ranging, with a significant contribution to key themes such as National Education Policy 2020, academic leadership, ICT, IoT applications, and sustainable development goals. Dr. Matani has worked extremely on research methodologies, climate change, and the pursuit of net zero goals, demonstrating his deep commitment to both education and the environment. His work in design thinking, energy, and entrepreneurship has also garnered much recognition. Dr. Matani has been awarded 2 patents for his innovative work, and his scholarly contribution have earned him 11 Best Paper Awards in various prestigious conferences and seminars held at institutions like IITs, NITs, and AICTE approved institutions, universities. With over 100 publications in international journals and having presented more than 100 papers at conferences worldwide, Dr. Matani is widely regarded as a leader in his field. He has also guided 3 PhD scholars to successful completion of their doctoral studies at Sant Gajbaba Amravati University, further commencing his role as the mentor and academic leader. Dr. Matani has delivered over 60 keynote addresses and lectures, including expert talks at faculty development programs and short term training programs, and coordinated 12 training programs, demonstrating his passion for continuous learning and knowledge sharing. We are truly fortunate to have such a distinguished scholar with us today. Please join me in welcoming Dr. Ashok G. Matani, a truly in this field of education, research, and innovation. We welcome you, sir.
Thanks
Thank you,
for
ma'am.
kind introduction. Today's topic for discussion is, yes, should I start?
Yes, sir. We can, sir.
Yes. This today's topic is AI technologies and satellite imagery improving water accounting towards smart agriculture. Now we have seen that artificial intelligence powered crop optimization and machine learning in agriculture are now changing these smart farming or precise farming, what we call today. These techniques, AI and ML, use predictive analytics for farming and AI-driven disease management to make farming more efficient and green. This we are finding even some robots were used in revolutionizing agriculture with AI.
Sir, there is any PPT?
Yes, screen sir, this PPT is visible, sir. PPT is
Sir, shall I?
visible.
No, sir. Just 1 minute, sir.
Sir, not
So now you
visible
share,
chat.
sir. So now you share, sir. Now you share,
One
sir.
minute. 1 minute. 1 minute. Again, I am sharing.
Yes, sir. Just 1 minute.
Now it is okay.
Sir, it's not sharing, sir.
Yes, it is okay now.
No, sir.
Yeah, sir. Yes, sir. Yes, sir. It's sharing now, sir.
Okay. Okay. No problem.
Yes, sir. It's clear now, sir. Yes.
Yes. This topic is AI technologies and satellite imagery improving water accounting towards smart agriculture. Now we have seen that this artificial intelligence powered crop optimization and machine learning in agriculture are changing this precise farming or smart farming. These techniques use predictive analytics for farming and AI driven disease management to make farming more efficient and green. Here we are finding a robot is helping or assisting in agriculture work. These are different topics are these areas of AI in today's world in which automation, personalization, predictive analytics, healthcare, and safety and security. These are different components of AI in which this machine learning, then speech recognition is there, then vision, natural language processing, then expert system, planning and optimization, and robotics. This is the potential of AI, and by this 2032, it is going to $1304 billion. This these are different components of AI, and this we are finding how AI is revolutioning our day-to-day life. Almost every aspect of our daily life, personal life, is also affected by AI nowadays. AI have gained so importance. Almost all areas of our day-to-day life, this AI is used, implemented. Even now, AI was used in a Mahakumbh Mela at Prayagraj for different purposes. So this is even when our honorable PM sir has visited Paris, and he was means vice chairman of this Paris meet AI meet, and the next AI meet will be in India. Means we can imagine how important AI is. Even government of India have made special budget provisions for AI applications. Even government of Maharashtra has announced AI university in India. That will be first university in India. It is established by government of Maharashtra this year. Within 1 month, you will be seeing that this new AI university is established in Maharashtra. This will be the first of its kind in India. Even all IITs and NITs are offering now specialized courses on AI and ML. Here we are finding these different potential or this scope of AI applications. Here we are finding one this smartphone. It is used in for different purposes in agriculture. So these are different applications. These are the human-like capabilities of super AI, in which here subconsciousness, beliefs, desires, cognition, emotional intelligence, subjective experience, behavioral intelligence, and super AI. This These are different types of AI in which this based on capabilities, that is narrow AI, super AI, and general AI. And based on functionalities, it is reactive machine, limited memory, theory of mind, and self-aware. Now we have seen that agriculture is the cornerstone of human civilization, evolving from these hand tools to sophisticated machinery, now to cutting-edge technologies. As the global population grows and environmental challenges intensify, AI emerges as the transformative force, revolutioning agriculture by enhancing decision making, increasing efficiency and labor shortage, optimizing water management, and shaping the future practices. Even this AI in agriculture market is projected to reach $7,854 million by 2030. These AI-powered systems can analyze images captured by drones or sensors to detect early signs of crop disease. By identifying these subtle changes in plant color, texture, or structure, these systems can alert farmers to potential issues. This is current state of AI in agriculture market in which we are finding. This is the means statics figure in which this is increasing at the compounded average growth rate of 23.1%. This with increasing use of AI, take this global smart manufacturing market, it is going to reach this 650 billion US dollars. And here we are finding this evolution of precision farming, what today we call that is smart farming or precision agriculture or precision farming. These leverage cutting edge technology, including AI, machine learning, sensors, and data analytics. These are different technologies used in this machine learning and deep learning. These AI subsets enable systems to analyze vast amounts of agriculture data, identify patterns, and make predictions or recommendations. This computer vision, this technology allows AI system to see and interpret visual data from cameras and drones, useful for crop monitoring and automated harvesting. Then sensor technology, various types of sensors, that is soil, weather, GPS from and big data analytics. Then cloud computing is also used here in this, and 5G networks. Latest what we are seeing that 5G is now introduced 3 months back in India, and this is also used in for faster, more reliable communication between IoT devices and central systems and real-time decision making. This precision agriculture uses technology to gather and analyze the data. This helps farmers make better decisions for more efficiency and productivity. This In this case, AI algorithms analyze data to predict crop growth and detect disease. This helps farmers to plan irrigation and fertilization, leads to healthier crops and more yields. Variable rate technology helps farmers to apply resources like water and fertilizer based on the field's needs. According to that, we can cut waste and help the environment. This precision farming uses IoT sensors to collect important data. These sensors track soil moisture, nutrient levels, temperature, and more. Even drones with imaging tech make high resolution photos from above and give farmers a detailed look at their heights. By combining this data from satellite sensors and manual checks, farmers get full picture of their farm. This helps them to make better decisions. These precision agriculture technologies, these are GPS, IoT, and sensors. And these are different, means technology in left side in key benefit, then adoption rates, and what technology is used in that. In which here, using GPS, this precision equipment tracking, field mapping, data collection. In this, 27% of US farms or ranches use precision agriculture practices. Then IoT devices, this real-time environmental data monitoring, remote access. It is increasing with focus on small-scale farmer access. Then sensors, detailed data on weather, soil, crop health, and more. This expanding with $200 million in US government funding. To this here we're finding in which one this drone is used and taking this picture after this 3D mapping of this particular segment of soil or this cultivated land, we can verify what is the quality or what is the position of this crop and when we should cut or sell. This AI in crop monitoring and management. These AI technologies are making impact on crop monitoring and management. These drones equipped with high resolution camera and sensors capture detailed images of fields, allowing AI algorithms to analyze crop health, detect disease, and assess the nutrient levels. This real-time data empowers farmers to take proactive measures, applying fertilizers or pesticides precisely where needed, thereby reducing waste and environmental impact. This disease detection. These AI-powered systems can analyze images captured by drones to detect early signs of crop disease. Nutrient management. Here, AI helps to optimize nutrient levels by analyzing soil data. By understanding these nutritional needs of crops, farmers can apply fertilizers more efficiently, reduce waste, and minimize the environmental impact. Yes, slides are moving, no?
Yes, sir. Moving, sir.
Okay. Now then, this weed identification and control.
இவர் பாருங்க வெள்ளிங்க பாருங்க.
Organizers, can you please mute everybody except the leader?
These AI algorithms can distinguish between crops and weeds in images, facilitating targeted weed control. This enables farmers to use herbicides selectively, reduce the need for widespread application, and promote sustainable farming. Even crop health monitoring, these drones equipped with AI-powered cameras capture multi-spectral image of fields, allowing for detailed analysis of crop health. AI algorithms can identify stress factors such as water scarcity or pest infections, infestations and guiding farmers in implementing these precise interventions. Then precision and efficiency. This AI enables precise targeting of interventions, whether it be apply fertilizer, pesticides, or water. This precision leads to more efficient resource utilization, reducing cost and minimizing environmental impact. Then timely intervention. Early detection of diseases or nutrient deficiencies allows farmers to intervene promptly, preventing the escalation of problems. This approach contributes to healthier crops and higher yields. Then optimize resource use. These AI-driven recommendations for nutrient application and irrigation help farmers optimize the use of resources. Data-driven decision making. This wealth of data generated by systems provides farmers with valuable insights. This data-driven decision making empowers farmers to adapt quickly to changing conditions. Then increase productivity. By leveraging this AI for crop monitoring and management, farmers can increase productivity through improved crop health, reduced losses, and more efficient use of resources. Then predictive analytics for weather and yields. These predictive analytics driven by AI has become the game changer in agriculture. These machine learning models analyze historical weather data, soil conditions, and crop performance to predict future outcomes. Farmers can access accurate forecasts, enabling them to plan planting and harvest activities. This improves yield but also minimizes loss due to adverse weather events. Then automated machinery and robotics. This integration of AI into automated machinery and robotics is reshaping the physical landscape of farming. These smart tractors equipped with AI systems can navigate fields for farming tasks such as planting and harvesting with precision. These robotics play a crucial role in activities like weeding, fruit picking, and packing. Then AI-enabled irrigation systems. This water scarcity poses significant challenge in agriculture. By analyzing this data, AI algorithms optimize irrigation schedules, ensuring crop receive the right amount of water at the right time. This not only conserves the water but also improves crop health and reduce the operational cost. Here we are finding one robot is picking that tomato, which is means, it is now ready to sell or in market. This is one picture in which these IoT applications are used in smart precise farming. Even smart tractors which we are using here, that is there. This digital transformation in agriculture, some opportunities and challenges are also there. These are opportunities: improved resource management, then enhanced ability to adapt climate change, creation of new job roles in Agtech and data analytics, improved food security. Then slight challenges are also there. This ensuring equitable access to technology, then addressing privacy concerns, managing job potential displacement due to automation. This is also one of the risks in that, or fear in that. Probably this will be replacing the human jobs. Then balancing the benefits of AI with energy consumption and environmental impact. These are challenges. And these are different solutions. If whatever we have seen that challenges are drawbacks, and according to that, some AI powered solutions are also there. In the farming aspect, when water usage is there, in traditional method, it is high content, high water is used. But in AI powered solution, it is 30% reduction water is used. Pesticide application, in traditional it is frequent, whereas in AI powered segment or a solution, this is targeted and as and when needed. Energy consumption in medium, whereas in this is depends on implementation. Crop yield, it is variable, it is increased nearly 10 to 20% on average. Soil health often degraded over time, but here improved through precise management. In carbon footprint, it is in traditional method, it is high, where it is reduced. That varies by implementation. So these are different aspects of farming, and these which we've seen traditional methods of using this, and here AI powered methods. Then here we are finding one lady is having a smartphone, and she is means operating that or controlling or governing this agriculture in one form. Here drones are there. Even here robots are used in this. These are different applications of AI in agriculture, that is optimizing automated irrigation systems. Here, AI algorithms enable autonomous crop management. When combined with IoT Internet of Things sensors that monitor soil moisture, weather conditions, algorithms can decide in real time how much water to provide. This autonomous crop irrigation system is designed to conserve water while promoting sustainable agriculture and farming practices. This is how drip irrigation is used in that. Then detecting leaks or damage to irrigation systems. Here, AI plays a crucial role in detecting leaks in irrigation systems. These machine learning models can be trained to recognize specific signatures of leaks, such as changes in water flow or pressure. This AI also incorporates weather data along the crop water requirements to identify areas with excessive water uses. By automating this leak detection and providing alerts, AI technology enhances water efficiency, helping farmers to conserve these resources. Then crop and soil monitoring. This wrong combination of nutrients in soil can seriously affect the health and growth of crops. By identifying these nutrients and determining their effects on crop yield with AI, allows farmers to easily make the necessary adjustments. This is where we are finding this how this cultivation is going on with the monitoring of this smart or IT applications here. Then detecting disease and pests. So as this soil quality and crop growth, computer vision can detect the presence of pests or diseases. This works by using AI in agriculture projects to scan images to find mold, rot, insects, or other threats to crop health. This helps farmers to act quickly in order to exterminate pests or isolate crops to prevent the spread of disease. AI technology is used to detect apple black rot with accuracy of over 90%. It also identifies insects like flies, bees, moths, etc. with the same degree of accuracy. Here, monitoring livestock health. There is one company called Catalai. It has developed a solution that uses drones, cameras together with computer vision to monitor cattle health remotely. It detects typical cattle behavior and identifies activities such as birthing. This cattle eye uses AI and ML solutions to determine the impact of diet alongside environment conditions on livestock and provide valuable insights. This helps farmer improve the well-being of cattle to increase the milk production. Here we are finding how it is used. Then intelligent pesticide application. Up till now, farmers are aware that application of pesticide is ripe for optimization. With both manual and automated application, process have now notable limitations. Is applying these pesticides manually offers increased precision in targeting specific areas. This automated pesticide spraying is quicker and less labor intensive. These AI-powered drones provide the best advantage of each approach while avoiding their drawbacks. Drones use computer vision to determine the amount of pesticides to be sprayed on each area, then yield mapping and predictive analytics. This uses ML algorithms to analyze large data sets in real time. This helps farmers understand the patterns and characteristics of their crops, allowing for better planning. By combining these techniques like 3D mapping, data from sensors, and drones, farmers can predict soil yields for specific crops. Data is collected on multiple drone flights, enabling increasingly precise analysis with the use of AI algorithms. These methods permit the accurate prediction of future yields. Then automatic weeding and harvesting. This one robotic process automation is used for automatic weeding. This robot is already used with effective efficiency. Then sorting harvested produce. AI is not only useful for identifying potential issues with crop, they are also playing role after product has been harvested. Most sorting processes are traditionally carried out manually, however, AI can sort produce more accurately. Computer vision can detect pest as well as disease in the harvested crops. It can grade produce based on its shape, size, and color. This enables farmers to quickly separate produce into categories, for example, to sell to different customers at different prices. Here we have find that these different types of different grades of apples are in four different rakes are these trays you are finding in which all these are sorted with the help of AI. Here we have seen that in market, when we go per market, the different qualities of apple are there from 100 rupees kg to 300 rupees per kg. These are this rate of the, of course, nutrient value of apples is nearly at least for 100 rupees per kg apple, this nutrient value, and in 300 rupees per kg apple, this nutrient value hardly changes, nearly 20 to 25%. Remaining 75% is almost same nutrient value. But considering this aesthetics and paying capacity or luxury, what we call the status point, the people are purchasing that somewhat a higher cost, or some what we call that aesthetic point, or that. But some those people, poor people or less income people, they are also purchasing that 100 rupees apple, and they are also eating that. Hence, here AI algorithms are helping in identifying this harvested crop. Then surveillance. This farms are common targets for burglars. It is hard for farmers to monitor their fields around the clock. Animals are another threat, and they are also means damaging these crops. And combined with this video surveillance system, computer vision and ML can quickly identify security breaches. These slight changes of AI in agriculture are large upfront cost. Of course, when AI is used, because AI infrastructure, its software, and its experts person's salary, it is somewhat costly as compared to conventional. Since technology is new, and then reluctance to embrace new technology, because it is one fear in minds of farmers or less educated people. This will be causing, because whenever there is change, resistance is always there. This is also with AI applications in agriculture. Then lack of practical experience with new technology, because new technology is there, but the skilled people are less number of persons are available in India. Hence, this is also one of the challenge or drawback in our country. And lengthy technology adoption process, technological limitations, because in some remote areas, probably these robots and with sensors limitations can adapt to changing farming environment difficult, or some remote places, network problems, or this access road accessibility, or infrastructure problems are also there. Then privacy and security issues, of course, when IoT applications are used, AI is used, cyber security aspect is also involved there. This is also causing some challenges or drawbacks in that, but it will be overcome when security is there, because now people, expert people are now available, in which this uh, cyber security is now easily maintained with proper means as per norms, legal norms. Here we are finding with these how drones are used and smart tractors are used in even this smartphone with one farmer, and he's operating that. Then, considering these challenges, and here are some remedies or strategies to overcome these hurdles in implementation of AI in agriculture. That is high upfront cost for advanced technology. Government subsidies and tax incentives are also available. Lack of specialized expertise, technical skill, collaborative efforts between stakeholders. MOU can be signed, or some experts are also deputed. The resistance to change within the agriculture community, effective knowledge sharing and training programs are organized. Then demonstrating these tangible benefits of AI driven farming. Then these are different real world applications and success stories where we are using these AI applications in different processes in precision agriculture. This is left side, it is technology, what technology is used, what are applications, and what are here benefits. This John Deere, this is the most leader in agriculture. This company is market leader in agriculture market. This John Deere's AI powered equipment, this optimizes planting, watering, and fertilizer process. The benefits, it increases crop yield and reduces the resource waste. Then Terrain's AI-driven aerial imagery. This monitors crop health and soil conditions. See, this identifies issues early to improve crop health and yields. Then AWARE, it is name of company, that AWARE's predictive analytics. This offers insights into weather patterns. This reduces the risk of crop failure and enhances the planning. Then Blue River Technology, seed and spray robots. These precisely eliminate weeds and among crops. This decreases the need for herbicides. Then Connect Cross IDA. This uses AI for livestock monitoring. This boosts livestock health and productivity, reduces labor costs. So these are the different case studies in which this productive analytics for crop yields, then automated pest identification, precise farming, then drone assisted aerial survey, machine learning for soil health, smart irrigation systems. By using this AI, we can adopt these according to changing weather conditions so that right amount of water at the right time is provided. No loss of water or no excess water should be given. Then AI powered sorting robots, we have seen that. Then forecasting market demand also. AI algorithms forecast demand and help streamline the agriculture supply chain, reducing food waste. Because we have seen that.
Hello, we can't hear anything.
The voice is not audible.
Hello, Ashokji, we can't hear you.
Yes, now it is okay.
Yes, sir. Okay.
Yes, sir. Okay, yes.
Okay, okay. Now, this forecasting market demand, these AI algorithms forecast demand and help streamline the agriculture supply chain, reducing food waste. Then chatbots for farmer assistance. Nowadays, chatbots are also popularly used in India also. This implementing AI chatbots that provide farmers with interface to instant access to their customers or sellers. This gives farmers the instant advice on crop management, pest control, and market trends. Even this 24 by 7 helpline offers solutions and support to improve farm productivity. Then collaborative AI research and platforms. So these farmers and AI companies are developing better AI tools tailored to specific farming needs. These platforms encourage innovation and help farmers stay competitive in rapidly evolving market. Then these rise of AI agriculture companies, these are 10 pioneers of innovation and how it is going on at world level and which companies are providing what type of services. This climate corporation, this company is at the forefront of agriculture, AI agriculture, offering digital platform that uses data science to help farmers improve their productivity. Their predictive analytics for crop health is game changer, enabling better planning and risk management. Then Blue River technology, this known for their sea and spray technology. Blue River technology uses computer vision and machine learning to make weed control more efficient. This precision spraying reduce herbicide usage significantly, contributing to more sustainable farming AI practice. Then John Deere. This company is having integrated space technology and AI and advanced data analytics tools to monitor crops, assess field conditions, and optimize resource allocation, leading to improved yields and reduced environmental impacts. Their precision farming tools are helping farmers plant and fertilizer more effectively than Aero-Environment Quantix. This is specialized in drone technology. This provides with detailed imagery that can be analyzed using AI to improve crop management and health. Then trace genomics. This is also By analyzing soil samples with machine learning, these trace genomics help farmers understand their soil health and how to enhance is offering personalized recommendations to improve crop health and yields. Then ratio. This ratios is smart irrigation systems embody how AI can help agriculture by using weather and soil moisture data to conserve water and reduce costs. This ratio utilizes AI to enable efficient crop production and real-time monitoring. Then harvest crow robotics. These strawberry picking robots demonstrate how to use AI in agriculture. These robots identify and harvest ripe berries efficiently, address labor shortage, and reduce the waste. These are focused on automating the crop management, harvesting, and picking on specialty crops, starting with strawberries, to address labor shortage and increase efficiency. Then IBM Watson decision platform for agriculture. This IBM's platform uses AI to optimize the agriculture supply chain. This combines AI analytics and predictive insights with IT data to help stakeholders make faster, more informed agriculture decisions. Then Plantix. This is free AI-driven mobile application that adds farmers with information on disease, pest infection, and nutrient deficiency. This offers an app that uses AI to diagnose plant diseases and pests. Then Grower's Edge. This uses AI to analyze data and provide financial and risk management tools to farmers. It provides fintech and data solutions for the agriculture sector to make agriculture more innovative and sustainable through risk management and financial options. Here we are finding how this AI and robots are used in these are different benefits of adopting IoT and AI in agriculture, in which reduction of risk in sales and business process, deployment of predictive systems, increase efficiency on the land, minimize labor costs due to smart technologies, smart agricultural decision making through data analytics, automated agriculture machines for improving crop quality, and limited use of pesticides and healthier soil quality. To hear how IoT and AI are changing the way of farming, in which these smart greenhouses, agriculture robots, intelligent spray houses, agriculture drones, crop and soil monitoring sensors, then cost price forecast and yield predictive tools are used. Precision farming, just like share market, we are having same in AI also used in agriculture. Because agriculture is, we are seeing that, take example of today, value of tomato. It is common vegetable. We are using, everybody is using in vegetables or making vegetables at home or at or menu, eating menu for vegetables. So these now vegetables are available rupees 15 rupees per kg now at present. Whereas 2 3 months back it was nearly 100 rupees per kg. Same case of onions also. Onions are now available at 30 rupees per kg, whereas it has gone up to 100 rupees. And that also means this is guiding when to store this or when to sell that. To this crop price analytics, this is helping for farmers. Then precision farming systems, livestock tracking, real-time weather tracks are also there because now alerts are sent so that these farmers can take a decision accordingly. Even I have read one news in which now Google have developed one app in which just in our mobile you put click one app of Google's app, it will alert about the earthquakes because recently last 10 days back one slight earthquake was in Delhi of Richter scale less than 4, hence it was not that much means hazardous or any loss was there, just it was indication, but it gives alerts. Google have developed that app in which we can give it is giving alerts to residents, those who are operating that apps in their mobile smartphones. At least this technology is so advanced in which these weather trackers are these quake alerts are also possible nowadays. In case if this is app is activated or installed in our maps, so at least we can save the life and we can protect our property also, or at least life during if we cannot stop for the earthquake, but at least we can take preventive measures so that minimum loss to life is there. These alerts are now even possible on our smartphone. Then pest detection tools are also there. So I will share one video in which we will know okay what technology is used in foreign countries and how it is affecting agriculture. I'm telling one showing sharing one slide. I'm sharing 1 minute.
Imagine a world where farming isn't just hard labor under the sun.
Now it is seen to you.
But a high-tech operation driven by artificial intelligence. From robots planting seeds to algorithms predicting weather patterns, AI is revolutionizing the way we grow our food. And it's happening right now. With climate change, a growing global population, and shrinking farmland, traditional methods just aren't enough. The future of agriculture is smart, efficient, and sustainable, and it's powered by AI. So how exactly is AI feeding the future? Let's start with precision agriculture. This is where AI really shines. Imagine being able to monitor every inch of your field in real time, knowing exactly how much water, fertilizer, or sunlight each plant needs. AI-driven systems are helping farmers analyze data from sensors, satellites, and drones to optimize crop growth. Instead of guessing, farmers now have detailed insights, allowing them to save water, reduce chemicals, and boost yields. And it doesn't stop there. Autonomous machinery is changing the game. Self-driving tractors, AI-powered drones, and even robotic harvesters are taking over the heavy lifting. Literally. These machines, guided by AI, can work around the clock without human intervention. They plant, water, and harvest with extreme precision, reducing labor costs and increasing efficiency. The best part? AI doesn't just do the work, it learns from it. As these machines gather more data, they get better at farming, continually improving operations over time. But what about detecting problems before they even happen? That's where crop monitoring and disease detection come in. With AI-powered drones and satellite imagery, farmers can monitor their crops 24/7. These systems can spot early signs of pests, diseases, or nutrient deficiencies long before they're visible to the naked eye. Next up, predictive analytics. With real-time monitoring, it also helps farmers plan for the future. By analyzing weather patterns, soil conditions, and even market trends, AI can predict the best time to plant crops, the most profitable crops to grow, and even the likely impact of future weather events. This gives farmers the power to plan ahead and make smarter decisions, reducing risks and maximizing profits. But it's not just about efficiency. AI is making farming more sustainable. With the ability to precisely manage resources like water and fertilizer, AI is helping farmers reduce waste and minimize their environmental impact. As the world faces climate change and resource scarcity, sustainable farming is no longer optional. It's essential. AI is giving us the tools to grow more food with fewer resources, ensuring we can feed a growing population without depleting the planet. Of course, with any new technology, there are challenges. Not every farmer has access to AI-powered tools, and there are concerns about data privacy and ownership. But as AI continues to evolve, it's clear that it holds the key to solving some of the biggest challenges facing global agriculture. So what does the future look like? A world where farms are smarter, more efficient, and more sustainable. If you're as excited as we are about how AI is changing the future, don't forget to hit the like button and subscribe to our channel for more insights into AI and technology. And if you're curious,
Another slide I'm sharing in which we can hear how this AI in
Welcome to this insightful video on smart irrigation systems with I,
where we explore how artificial intelligence is transforming water management in agriculture. This innovative approach is helping farmers optimize water usage,
Yes, it is
reduce
now
waste,
visible.
and ensure healthy crops, all while conserving
Yes,
precious
sir,
water.
visible, sir.
Yeah, visible.
Dive in and uncover the future of irrigation. Water is the lifeblood of agriculture, but inefficient irrigation leads to overuse, increased costs, and environmental challenges. Traditional irrigation methods often rely on fixed schedules or manual monitoring, which may not align with the actual needs of the crops. Smart irrigation systems powered by AI are changing this narrative by using data to make precise and timely irrigation decisions. These systems rely on sensors, weather forecasts, and AI algorithms to determine the exact amount of water needed by crops, reducing waste significantly. Globally, agriculture accounts for approximately 70% of freshwater use, and AI-driven smart irrigation systems can cut water consumption by up to 50%. For example, in Australia, a farm implementing AI-based irrigation saved 30 million litres of water in a single year. Smart irrigation systems use soil moisture sensors that monitor water levels in real time, ensuring that crops receive just the right amount of water. A vineyard in California reduced water usage by 25% while improving grape quality by adopting AI-based irrigation systems. AI also integrates weather data into irrigation planning. By analyzing rainfall predictions, smart systems avoid unnecessary watering. In Spain, olive farmers used AI-driven irrigation to cut water usage by 20% during a dry season, preserving their harvest. Precision is key in smart irrigation. These systems divide fields into zones, allowing tailored watering for different crops or soil types. In India, rice farmers using AI irrigation tools reported a 30% increase in yield by managing water more efficiently. Another breakthrough is AI-powered drip irrigation, which delivers water directly to the roots of plants, minimizing evaporation. A tomato farm in Israel reduced water evaporation by 35% with AI-driven drip irrigation, ensuring healthier crops. AI isn't just about saving water, it's also about boosting productivity. With optimized irrigation, crops grow faster and produce higher yields. Studies show that AI-based irrigation can increase crop productivity by up to 15%, making it a win-win for farmers. Drones equipped with AI sensors are also being used to monitor crop water needs from the sky. These drones identify dry areas and guide irrigation accordingly. In Brazil, drones helped sugarcane farmers cut water usage by 40%, saving costs and preserving resources. Smart irrigation systems are particularly beneficial in regions facing water scarcity. By optimizing usage, they help combat drought and ensure sustainable farming. For instance, in sub-Saharan Africa, AI irrigation systems have enabled farmers to maintain productivity even in water-stressed areas. AI also aids in detecting and fixing irrigation system leaks. Sensors alert farmers to leaks instantly, preventing water loss. A citrus farm in Florida saved thousands of gallons of water by using AI to detect and repair irrigation leaks. Another exciting development is the integration of IoT with AI for smart irrigation. Connected devices allow farmers to control irrigation systems remotely through smartphones. In the Netherlands, farmers use AI-powered apps to adjust irrigation schedules, saving time and achieving 20% better water efficiency. AI irrigation isn't limited to large-scale farms. Startups are creating affordable solutions for smallholder farmers, making this technology accessible to all. A small farmer in Kenya increased maize yields by 50% using an AI-enabled irrigation app that costs just a few dollars a month. The economic benefits of smart irrigation are clear. Farmers save on water, energy, and labor costs, improving their bottom line. Globally, the smart irrigation market is expected to reach $3.7 billion by 2026, highlighting the growing demand for these systems. Implementing smart irrigation systems does come with challenges, including upfront costs and the need for technical knowledge. Governments and organizations are stepping in to bridge this gap by offering subsidies and training programs for farmers. For example, the Indian government is providing financial assistance to encourage the adoption of AI-driven irrigation systems. Collaboration between tech companies and agricultural communities is also driving innovation in this space. Companies like Netafim and Rainbird are developing advanced AI solutions that cater to diverse farming needs. The potential of smart irrigation systems with AI is enormous. By conserving water and boosting productivity, they are paving the way for a sustainable agricultural future. Imagine a world where every drop of water is optimized, ensuring food security for a growing global population. AI is not replacing traditional farming practices, but enhancing them with tools to meet modern challenges. By integrating AI into irrigation, farmers can adapt to climate change, reduce resource waste, and improve their livelihoods. Thank you for joining us on this journey into the world of smart.
Now, this PPT is visible?
Yes, sir, it's visible, sir.
Okay, okay, okay. I have shown you these videos so that we should have the imagination or the clear clarity ki how these AI applications are used in different parts of the world, because they have demonstrated different case studies, 5 to 6 countries cases, in which how this is implemented in different advanced countries also, and least developed countries also. Means by seeing this, it indicates yes, it is AI applications in agriculture are possible, and it is increasing this productivity of agriculture systems and resources. Here we are finding these agriculture robots are also there. These help cut down manual efforts and save time by performing multiple tasks on farms. These robots can sort the yield based on quality and pack them in less than traditional methods. Then intelligent spraying hoses. These AI-driven hoses, these drones are useful in monitoring the vegetation index of crops and their health. These sensors keep check on insect infestation and disease. These devices spray pesticides on infected plants. This reduces the use of chemicals. Then crop price forecast and yield product prediction tools, just like we are having share market, same is used here in agriculture also. These technologies such as AI, ML, big data are used for helping the farmers predict yield from their crops. This farm mapping helps in calculating accurate field per hectare. Farmers study different parameters such as rainfall, pesticides use, pH level, temperature, and other atmospheric conditions. Then crop and soil monitoring sensors. These robots and drones with thermal or multispectral sensors monitor crop and soil health at all times. This helps in control irrigation and spraying of fertilizers. These also read biome levels of soil to ensure high nutrient value in crops. This AI also analyzes soil properties to suggest the best crop choice to maximize the profitability. Then pest detection tools. These AI systems are also coupled with low-cost satellites to obtain images of the farm. In some cases, intelligent spraying is also automatically initiated to avoid the spread of pests. Then different predictive analytics are also used. Database decisions are also used here. Then farm management software is also there. This farm management software using AI gives real-time information on one or many aspects of farming. Through the incorporation of this technology, it assists farmers in making the right decision in terms of IR4, FEA, IPM, which improves operations and returns. And according to McKinsey, AI can bring improvement in farm management by up to 30% by improving resource efficiency and cutting down the expenses. Maximizing efficiency and minimizing costs. This AI's primary goal is to enhance the efficiency and reduce costs with precision agriculture. Even according to one international food policy research institute, They have predicted that precision agriculture can lower fertilizer use by up to 25% and at the same time increase crop yield by 20%. Means there are both benefits: less fertilizer consumption or usage, automatically sustainable development or environmental protection, and plus crop yield means output or efficiency productivity, what we call that. Means both are purpose are fulfilled with the help of AI applications. Even addressing labor shortage with automation. Because since agriculture is labor intensive industry or sector in which more human efforts are required for conventional farming, but with the help of this AI driven automation, this performing tasks traditionally is reduced by AI tools or AI sensors. This AI is driving advancements in innovative farming such as vertical farming. This involves growing crops in stack layers in controlled environments. This optimizes conditions such as light, temperature, humidity, reducing the need for herbicides and pesticides. This results in better quality produce, increased yields, and higher returns on investments. This, according to the report by Agri-Tech consultant, vertical farming can yield up to 100 times more produce per square feet compared to traditional farming methods. Then automation in farming process. Then advanced agriculture machinery, some robots and smart tractors are then used, smart irrigation systems and robotic harvesters are also used. These machines operate continuously without fatigue, increase productivity and reduce the need for human labor. These autonomous tractors can plow fields and plant seeds with precision, while robotics harvesters efficiently gather crops with minimum human intervention. And according to the report by World Economic Forum, autonomous machinery can increase fieldwork efficiency by up to 40%, allowing workers to focus on strategic tasks. Enhancing water management also, AI also plays vital role in optimizing water use. Even lag detection, according to American Water Works Association, AI-driven leak detection can reduce water loss up to 50% in irrigation system because it is happening at present in majority of the almost all parts. This since water is freely available to farmers and most of the water is going wastage, even though it is not that much quantity is required for agriculture or irrigation purpose. But since no any cost is involved, water cost is involved, hence farmers are not that much conscious about this. And with the help of this AI-driven leak detection, it can reduce up to 50% losses or water consumption by 50%. Means if 50% water is saved, imagine what can be the situation because we are facing this clean water and in India, we are having the same quality of water is available for drinking, also for agriculture, also for car cleaning, also for clothing and bathing and other personal needs. Even optimizing water usage. These AI-powered irrigation systems can optimize this water use based on real-time weather forecast and soil moisture data, leading to saving up to 20% water. Crop and soil monitoring. This AI technology provides accurate real-time data to support these efforts. Soil health analysis. This, according to this University of Illinois, AI-driven soil health analysis can increase crop yield up to 15% by optimizing farmer applications, fertilizer application. Then real-time crop monitoring. These AI-powered crops power tools, including sensors and computer vision, monitor crop growth and detect issues such as disease or pests. These technologies provide detailed insights into crop health. Even one research by International Rice Research Institute indicates that AI-powered crop monitoring can reduce crop losses by up to 25% by detecting disease and pest early. Disease and pest detection. This AI enhances the capability through advanced image recognition and analysis. This accurate identification AI technologies, these systems can identify and classify different types of pests and disease with high accuracy, enabling more targeted and effective interventions. Then disease and pest detection. This, according to the study by Journal of Agriculture and Food Chemistry, AI-powered disease and pest detection can improve crop health by reducing reliance on chemical treatments. Then monitoring livestock health. These AI advancements extend to livestock management, where monitoring and improving animal health is also crucial for productivity and welfare. Even this remote monitoring, this one cattle eye, it uses drones and cameras to monitor cattle health remotely. This improves animal welfare by enabling early detection of health issue and allowing farmers to make informed decisions about feeding and care. Even I have seen on news channel 3 days back one buffalo. That one farmer he has shown that buffalo, and that buffalo is costing. You will be surprised ki what can be the cost of a buffalo. 5 crore rupees. Imagine the situation. If probably some of you might have also read that news item in news channels. Ki this buffalo is costing 5 crore rupees. Means imagine what is the cost of animal. Of course, that buffalo, he was telling the interview of showing that viewing that interview of owner of that buffalo, in which they have to maintain air conditioner for separate air conditioner for buffalo. Then different eating and other nutrients they have to provide that buffalo to make that buffalo in healthier condition. Means its cost is 5 crore rupees. That buffalo costs one animal costs 5 crore rupees. Then yield mapping and predictive analytics. This AI plays a crucial role in optimizing crop production and resource allocation through yield mapping and predictive analytics. This, according to the Food and Agriculture Organization, yield mapping powered by AI can increase crop yields up to 20% by optimizing planting and resource allocation. This predictive analytics, AI can predict crop yields with accuracy of up to 90%, enabling farmers to plan and manage resources more effectively. Increasing efficiency, AI is transforming the weed management and harvesting through advanced automation. This automatic weeding, these AI-powered weeding robots can achieve over 90% accuracy in weed detection and removal, reducing manual labor and herbicide use. Then automated harvesting. According to the report by Agriculture Robotic Institutes, automated harvesting can increase harvesting efficiency up to 50% and reduce labor costs by 40%. Then sorting harvested produce, just like we have seen that. AI can sort and grade produce with high accuracy, leading to better quality control and reduced labor cost. Even every government in all countries, they are protecting this and supporting these technologies and helping farmers, because farming is the backbone of any country. Of course, India is the we are agriculture since ancient times. We have seen that agriculture has played the key role in our economy. To hear this government is also supporting this crucial role in facilitating integration of AI into agriculture. Even some policies are also shaping the future of AI in farming. This this US Department of Agriculture, Agricultural and Food Research Initiative and US Origin Europe support research and innovation AI applications for agriculture. In India also, we are having digital agriculture mission aims to integrate AI and other technology to enhance productivity and sustainability in farming. These initiatives encourage the adoption of AI to address key challenges. Then future prospects for AI in there. These enhanced algorithms will improve forecasting and provide deeper insights, while integration of AI with blockchain and Internet of Things will create more robust agriculture systems. This increased automation and global collaboration will drive innovation and address global food security challenges. These are different top real life use cases for AI in agriculture in which this precision farming. This technology uses machine learning and data analytics. This example is John Deere's AI-powered equipment uses sensors and GPS to optimize planting, watering, and fertilizers. Benefits are applying this right amount of resource at the right time in the right place, increases crop yield and reduce the resource waste. Then crop and soil monitoring. In this, technology uses computer vision and machine learning. This example is Tarantis utilizes AI-driven aerial imagery to monitor crop health and soil conditions, identifying issues like nutrient deficiency or pest infection. Benefits helps farmer make more informed decisions, improving crop health and yields. Then predictive analytics for crop management. Technology uses machine learning and predictive analytics. This example is Aware provides farmers with predictive insights about weather patterns and their potential impact on crop. Benefits are reduces the risk of crop failure due to adverse weather and enhances planting or planting and harvesting. Then automated weed control. This technology uses machine learning and robotics. Example is Blue River Technologies. See and spray robots identify and precisely eliminate weeds among crops, reducing the need for herbicides. Benefits are minimizes chemical use, lowering cost and environmental impact. Then livestock monitoring and management. Technology uses IoT and machine learning. This example is Connectras IDA uses sensor data and AI to monitor livestock health and behavior, providing insights for better herd management. Benefits are enhances livestock health and productivity while reducing labor cost. Then agriculture drones. This technology uses computer vision and machine learning. This is company DJS agriculture drones. Assess crop health from the air, perform targeted spraying and map yields with precision. Benefits are increases crop monitoring and treatment efficiently, saving time and resources. Then yield prediction and optimization. Technology uses machine learning and data analytics. These examples are crop in leverages AI to analyze farm data, predict crop yields, and suggest optimizations for farm operations. Benefits are it enables better crop management, supply chain planning, and market readiness. Then supply chain management. In this, technology uses machine learning and blockchain. Here, example is IBM's Food Trust uses AI and blockchain to increase transparency in food supply chain from farm to table. Benefits are reduces food waste, ensures food safety, and strengthen the consumer trust. The next area is greenhouse automation. Technology uses machine learning and IoT. This motor leaps AI-driven automation systems optimize greenhouse climates, enhancing conditions for plant growth. Benefits are improves crop yield and quality while reducing energy consumption. Then gene editing for crop management. This technology uses machine learning and genomics. This Benson Hill uses AI to identify genetic traits that can improve sustainability, nutrition, and yields. This accelerates the development of improved crop varieties without GMO. Then pest and disease detection. This technology uses computer vision and machine learning. This Plantix app allows farmers to detect pests and disease early by analyzing images of affected crops with AI. These benefits are enables timely intervention, reduce crop damage, and improve the yield. Then water management. Here, technology uses data analytics and machine learning. This is name of company Arable. It uses AI to analyze climate and soil moisture data, provide irrigation recommendations for optimal water use. Benefits are it conserves water resource while ensuring crops receive adequate hydration. This market-driven prediction, this technology uses predictive analytics and machine learning. This Agribora, this is a company. This uses AI to predict market demand for various crops, helping farmers decide what to plant for maximum profitability. These benefits are aligns crop production with market demand, enhances farm income potential. Then satellite imagery for large scale monitoring. Here technology uses computer vision and machine learning. This Planet Labs, this is name of company. It offers satellite imagery analysis to monitor crop health and environment changes. This provides insights for better land management and environmental protection. Then automated harvesting systems. Here technology used are robotics and computer vision. This harvest grow robotics. This is name of company. It develops strawberry picking robots that use AI to identify and gently harvest ripe berries. This addresses labor shortage, reduce harvesting cost, and increase production efficiency. Even Sagu Bagu project in Telangana. This is the novel project in India. This prominent case study of AI in Indian agriculture is the Sagu Bagu project in Telangana's Khammam district. which utilizes AI-powered soil testing, crop quality assessment, and digital marketplace to significantly improve chili yields and farmer income by optimizing farming practice based on real-time data analytics. This initiative has seen a 21% increase in chili yield per acre and 8% increase in selling price for farmers. These key aspects of the Sagu Bagu are AI-driven advisory services. These farmers receive personalized recommendation through bot system based on soil conditions, weather data, and crop health analysis. The digital marketplace integration, this platform connects farmers directly with buyers, improving market access and price realization. Improve sustainability. This project promotes reduced pesticide and fertilizer usage by providing precise application recommendations. Then crop disease detection. Utilizing this AI-powered image analysis to identify crop disease like scab and yellow rust in wheat, this enabling time intervention to prevent significant yield losses. Then pest surveillance system. Utilizing machine learning algorithms to monitor pest populations and predict potential outbreaks, allowing farmers to proactively manage this pest control. Then precision farming. Leveraging this satellite imagery and weather data to create customized farming plans for specific yield areas, optimizing resource allocation like water and fertilizer use. Even Kisan e-Mitra chatbots. This AI-powered chatbot assists farmers with queries related to government schemes and agriculture practice, providing information in multiple languages. These are different key players in Indian AI agriculture. That is Cropin. It is Bangalore-based startup providing precision agriculture using satellite imagery and weather data analysis. Then World Economic Forum. This facilitated the Sagu Bagu project through Center for Fourth Industrial Revolution. Telangana state government played a crucial role in implementing this Sagu Bagu initiative in Khammam district. These different agriculture apps usually used in India are that is Kisan Suvidha, Pusa Krishi, Crop Insurance, Agri Market, IFCO Kisan, Kheti Badi, Organic Farming, Farmopedia, M Kisan. These are different government initiatives supporting AI in agriculture. This government of India is implementing numerous initiatives to bolster the AI-driven systems. This Future Skills Prime, this is Ministry of Electronics and Information Technology MIT-Y program, focus on reskilling and upskilling professionals in emerging technology, including AI. Then Digital India Bhashini. This project has made over 350 AI-driven language models accessible in 10 Indian languages, bridging linguistic barriers for farmers. The National AI Centers of Excellence. These collaborative hubs for startups to develop AI-based tools tailored for agriculture. Now I will show one more video which is
Did you know that the secret to healthier crops might...
1 minute, I'm sharing that video. Now it is okay?
Yes, sir.
The soil, monitored by tiny sensors. Welcome to the exciting world of smart farming and the Internet of Things. Smart farming is all about leveraging technology to enhance agricultural practices. By integrating tools like sensors, drones, and data analytics, farmers can grow crops more efficiently and sustainably. This means making better decisions about planting, watering, and harvesting, leading to increased yields and reduced environmental impact. So what exactly is IoT? The Internet of Things refers to everyday devices connected to the Internet and can communicate with each other. Imagine a soil sensor that measures moisture levels and sends real-time data to a farmer's smartphone. This empowers them to respond quickly to changing conditions, ensuring crops receive just the right amount of water. But why focus on soil health? Healthy soil is the foundation of successful farming. It provides essential nutrients for crops, which translates to better yields. Using IoT technology, Farmers can monitor soil health, detect issues early, and manage resources more effectively, leading to sustainable farming practices that protect our environment. In this video, we'll explore how smart farming and IoT are transforming agriculture today. You'll learn about innovative technologies being used in the field, hear from farmers who are making a difference, and discover the future possibilities for food production. So stay tuned to see how these advancements are shaping a more sustainable agricultural landscape. If you're curious about the future of farming or want to see how technology can make a positive impact, don't forget to like for more insights into the world of smart farming and IoT. Have you ever wondered how farmers can keep their crops healthy and thriving? And we will talk about how IoT enhances soil health monitoring, revolutionizing agriculture as we know it. Let's start by comparing traditional soil monitoring methods with IoT-based solutions. In the past, farmers relied on manual testing and visual inspections. This meant taking soil samples and sending them off to a lab. This is time-consuming and often leads to outdated information. But with IoT, farmers can monitor soil health in real time, drastically improving speed and accuracy. Imagine having instant access to critical data right at your fingertips. So what key soil parameters are monitored by IoT? First up, moisture levels. Sensors can measure how much water is in the soil, helping farmers know exactly when to irrigate. Next, pH balance is crucial for plant health, and IoT can track this continuously. Temperature also plays a significant role in crop growth, and IoT sensors ensure farmers are informed of any fluctuations. And let's not forget nutrient levels, like nitrogen, phosphorus, and potassium, essential for robust plant development. But how do these IoT sensors work? It's simple. These sensors are embedded in the soil, collecting data on various parameters. This information is then transmitted to cloud-based platforms or apps where farmers can access it in real time. It's like having a digital assistant for your crops. The benefits of continuous monitoring are immense. With real-time data, farmers can make quick decisions, like when to irrigate or add nutrients, ensuring optimal growing conditions for their crops. This not only boosts crop yields, but also promotes sustainable practices by preventing overwatering and reducing chemical use. By leveraging IoT technology, farmers are transforming agriculture for the better. They can respond to their crops' needs almost instantaneously, leading to healthier soil and bountiful harvests. Now, have you ever wondered how data is changing the face of farming? We're exploring the crucial role of data and analytics in smart farming, showing you how information can be turned into actionable insights for better agricultural practices. First off, let's talk about how IoT systems do more than just gather data. They provide actionable insights through data analytics. Farmers are no longer flying blind. With the right tools, they can analyze information about soil health, weather patterns, and crop performance. This means making informed decisions that can lead to healthier crops and better yields. Now, let's introduce machine learning and AI. These technologies can predict future soil conditions by analyzing historical data. For example, if a farmer notices that specific soil types in their field tend to retain less moisture, machine learning models can forecast when irrigation might be necessary, helping to prevent drought stress before it happens. This predictive insight allows farmers to act proactively rather than reactively. Another exciting aspect of smart farming is precision agriculture. Thanks to IoT technology, farmers can implement precise interventions like targeted watering and fertilizing, instead of applying blanket treatments across entire fields. This not only reduces waste, like over-fertilizing, but also improves soil conditions over time, creating a more sustainable farming environment. But how do farmers make sense of all this complex data? That's where data visualization tools come into play. Many farmers use user-friendly apps and dashboards that transform raw data into easy-to-understand visuals. With just a glance, they can see how soil moisture levels, pH, and nutrient content are trending, enabling them to act quickly and efficiently. Data and analytics are revolutionizing agriculture, empowering farmers with insights that lead to smarter decisions and sustainable practices. Now let's check out some real-world examples. One notable case is a smart farm in California that adopted IoT sensors to monitor soil moisture levels. By using these sensors, they reduced water usage by 30%, while increasing crop yields by 20%. This success story shows how technology can lead to better resource management and healthier soil. Another great example is a farm in the Midwest that implemented a data-driven approach to nutrient management. By analyzing soil data, they optimized their fertilizer applications, reducing costs and improving soil health significantly. Now, you might be wondering, what about the cost of these IoT systems? That's a valid concern. Fortunately, IoT solutions can be scaled for farms of all sizes, small, medium, and large. For instance, smaller farms can start with basic soil sensors that are affordable and easy to implement. As they see the benefits, they can gradually expand their IoT capabilities without breaking the bank. Larger operations can invest in more advanced systems that integrate with existing equipment, maximizing efficiency and productivity. But the benefits of IoT go beyond just cost savings. Let's talk about sustainability and environmental impact. By using IoT technology, farmers can reduce the overuse of water, fertilizers, and chemicals. For example, precise soil moisture monitoring allows farmers to water only when necessary, leading to significant water conservation. Additionally, optimized fertilizer application means less runoff into local waterways, protecting ecosystems and improving soil health over time. Success stories from around the world demonstrate that IoT isn't just a trend. It's a powerful tool for improving soil health and sustainable farming practices. Whether you're a small family farm or a large agricultural operation, the potential for growth and efficiency is immense. Next, we will talk about the next generation of innovations shaping the farming landscape. So imagine a world where IoT seamlessly integrates with drones and autonomous vehicles. In the future, drones will not only monitor crop health from the sky, but also analyze soil conditions and even deliver precise nutrient applications. Coupled with autonomous vehicles, farmers will be able to automate their entire workflow, making it more efficient and sustainable. And here's an exciting prospect. Using blockchain technology could enhance transparency in food production, allowing consumers to track the journey of their food from farm to table. This level of innovation will empower farmers to make data-driven decisions that promote healthier soil and crops. However, with great innovation comes challenges. Issues like data privacy, infrastructure costs, and the need for technical know-how can pose obstacles for many farmers. Fortunately, the industry is addressing these concerns. New policies are being developed to ensure data protection, and companies are creating cost-effective solutions that cater to various farm sizes. Training programs and resources are also emerging to help farmers adapt to this technological revolution. As we look ahead, it's essential to think about how IoT could transform agriculture, not just in terms of yield, but for the environment and future generations. By adopting these technologies, we can promote sustainable farming practices that protect our planet's resources and ensure food security for years to come. So, what are your thoughts on the future of soil health with IoT? How do you envision technology changing agriculture? We'd love to hear from you. Please comment below, share this video with others who might be interested, and don't forget to subscribe for more insights in
Now these PPTs are visible, no?
Yes, sir.
And I have shown you these three videos, which is these they have demonstrated in different. Of course, these are in advanced countries. These IT and AML applications are used, but in India also we are having one Sagu Bagu project in Telangana in Khammam district, which is Means it is novel case study for Indian farmers are how it is successfully implemented in Telangana, Khammam district. This in this they have of course this is the last year's data. This year data might have improved some more avenues or more areas, but at least last year's data, because I have taken this data from Times of India last year, which this news was published in Times of India. So from there, then from internet sources and Telangana government's website, this I have collected all this data. What is going in Saguwagu project in Telangana? This they have yielded this 21% increase in chili yield per acre. Imagine means how it is means increasing this efficiency of this farming or land soil fertility or soil productivity and 8% increase in selling price for farmers because this with the help of these apps these farmers now can decide to hold these yield or crop with them or sell according to that just like we are having share price variable market is share price market same is in agriculture means they will the predictive analytics will tell or advise these farmers for what time they should hold that keep in stock 10 days 15 days or 1 month 2 months and in that they can means after that they can sell or immediately they can sell of course that depends upon this health of this crop because if it is volatile take example of these tomatoes so we can store these tomatoes up to 1 week or 10 days or chiku suppose this is chiku fruit is there so 4 to 5 days if it is chiku is ripe so we can keep up to 3 days maximum otherwise we have to throw that otherwise it will spoil. That depends upon the nature of this yield or fruit or vegetable. Suppose onions and these potatoes are there, so be kept for 2 months, 3 months. Even potatoes are kept in cold storages. Majority of the crop is in Himachal Pradesh potatoes. From the in Himachal Pradesh, the cost of this is 2 rupees per kg. Whereas transportation cost it is costing 5 rupees per kg. Last year, these potato growers in Shimla and Himachal Pradesh, they have thrown their crop in river, and that TV news channel was showing that last year. The reason was the crop, the price of this potato was 2 rupees per kg, whereas logistics cost or transportation cost was 5 rupees per kg. Hence, they decided not to sell in market and they thrown their uh, potato crop in rivers and that TV news channels was showing that news means these apps also means give advices ki at what time they should hold that crop or yield or at what time they should sell that so these now smart apps are also now working even alerts also regarding forecast weather forecast or seismic or any earthquake signals or symptoms are there so these now Google have made one new development in their even our 5G mobile, we just going to keep that alert, earthquake alert, activate that, and it will give these alerts in adjoining areas. In probably these are this quake resistant area or quake prone area. So these means alerts are now so advanced and smartphones are now smart technologies coming in which we are getting these at fingertips. Just use of these smart technology is the need of the time. These are Sagubagu. This is the Indian and rural case. Khammam is not that much advanced district in Telangana. It is rural place, and they are using this. Farmers are using this. Of course, government of Telangana is helping them, guiding and advising them in this activity. But at least in rural places, to this successful project is going on, and it is the role model for India farmers, in which this digital marketplace integration is also there. Then include sustainability, this crop disease detection also because this is also one of the challenge because when crop is at its peak or ripe and suppose any weed or any yellow rust in wheat is there or any insects are there and they are destroying this crop then this helps these apps also helps ki immediately or they It instructs to spray that insecticides or other urea related sprays, and so that this crop health of the crop is protected, or this is, or we can at that time we can sell it per market to avoid this significant yield loss. Then post surveillance system, precision farming is also there. Kisan Mitra, this also chatbot is also working in India. Of course, this is means initiated by IFCO and Government of India, Ministry of Agriculture. They are this AI-powered chatbot also is farmers with queries related to government schemes and agriculture practice, providing information in multiple languages. So these different key players in India are also there. This we have seen that even different apps are there. 9 to 10 apps are also in of our these farmers. And so that is quite good number. Of course, this will be increasing day by day. When technology is there, more players will be coming in the market. The new players will be added, and they will be guiding and assisting these farmers, rural farmers. Because very rare educated people are entering in this agriculture market or agriculture business, since it is labor intensive, and moreover it is not that much significant return on investment is there up till now. But with the help of these IoT applications and different AI and machine learning algorithms, now this agriculture is proving to be, even now these engineers, those who have worked in multinational companies in US, they have left their jobs, and they are come in India, and they are doing this farming business now, since they were having their own lands, hundreds of acres in their locality, and they have entered in farming, and now they are successfully implementing these smart IoT applications or AI and machine learning algorithms, and now they are benefited from that. From my side, it is there. If any questions are there, welcome. Considering your time constraint,
Participants, do you have any questions? Any interaction with guest speaker? Dear participants, do you have any interaction with guest speaker? Dear participants,
if any suggestion are more than new, they want to share new thing in addition to this, welcome. In case anybody is knowing better than this, we can share. It will be benefit for all participants. Yes.
I think no questions, sir.
Okay, okay. Because time is over now. Now 9.02 time is there. Probably they hope
Yes, sir. I think time concerns.
time can
Yes,
be
sir.
the one.
Now I invite. Okay, sir. So now I invite Kadirvel sir, assistant professor, to deliver the keynote of the session. Kadirvel sir.
Okay, sir. Good evening, everyone. Good evening, everyone. I would like to express my sincere gratitude to Dr. Ashok G. Matani, sir, for his insightful presentation on AI technologies and satellite imagery in improving water accounting for smart agriculture. Your expertise in applying these technologies to revolutionize water management in agriculture has truly inspired us. We now have a clearer vision of how smart agriculture is becoming a reality and how it can address critical challenges in water conservation. Thank you once again, Dr. Ashokji Matani sir, for sharing your knowledge, and thanks to all for being part of this enriching discussion. Thank you. Thank you, sir.
Thank you, sir. Now I welcome Reshma ma'am, Professor English Department, to deliver the vote of thanks.
Good evening, all.
Yes,
Am I
ma'am, it's
audible, sir?
audible. Yes, ma'am, it's
Yeah.
audible.
Okay. On behalf of the management of Sri Venkateshwara High Tech Engineering College and the participants of this session, I would like to extend my sincere gratitude for your invaluable contribution to this candidate development program as a resource person, sir. Your expertise and insights have been truly enlightening, and we appreciate the time and effort you devoted to prepare in the topic of AI technologies and satellite imagery improving water accounting towards smart agriculture. Your presentation was really informative and engaging, sir. Thanks for being such a great resource. Thank you, everyone, for being a part of this session. Thank you so much, sir.
Thank you, ma'am. Participants, I shared the feedback form in message section, same as well as in the WhatsApp group. Kindly fill your feedback for this session 8. Thank you so much, sir, for your contribution of this Atal FTP.
Okay, should I leave?
Yes, sir. Thank you very much, sir. Dear participants, today's sessions are over. So tomorrow we will join again at the 6 p.m. I will share the Google Meet link in WhatsApp. Thank you so much for your presenting here. At the same time, one important announcement is there. Due on 1st March, day 6, 1st March, timing has been changed. I just confirm with the foreign expert the timing and then confirm you in through WhatsApp. Okay, once again I repeat, our 1st March, day 6, timing was changed because of the foreign expert timing issues. Once I confirm the timing from foreign expert and update you through WhatsApp, same as well as your mail ID. Please kindly check your WhatsApp, same as well as mail ID for the timing of foreign expert session. Thank you so much. We are going to signing off today. We will meet again on tomorrow. I already shared all the PPT in WhatsApp group, so kindly check the PPTs. If anybody want personally through mail, kindly text me. If we are unable to share to all the participants in mail ID because few of them attending only in the WhatsApp messages and WhatsApp links, but some of the participants not registered in the Atal portal also attending in the WhatsApp group, so we are unable to share the entire participants mail ID the all the PPTs. So kindly, if you want through mail means simply you just give a message, I will forward you. Thank you so much.